replicate that data, so that that change will be now present in all of the replicas as well. So of course the good part is there will be strong consistency. So if you try to read from any of the machine, you will get the updated data every time. But the problem part, you will have very high latency when we talk about the write operation, because when you write, you have to write in the primary, at the same time you have to update all of the replicas. You are waiting for that part. Okay, so it is used in the special system. So depending on what kind of system you are using, what kind of requirements you have, you can use one of the three replication modes. Now of course we said asynchronous is the most common, but it introduces the possible lag, which is also called as the replication lag. Now what is a replication lag? It means the replica is behind the primary by some time. Okay, so it will take some time for the replica to update as to the primary one. So if we talk about the replication lag, it can appear something like this. Okay, this is the replication lag. How? Say for example, the write operation happened in the primary at the time 10. Okay, and then when we talk about the replica, the changes apply at like 10:00:02. So the lag is of 2 seconds, correct? So the replica machine is behind the primary by 2 seconds. So it takes 2 seconds for the replica to update, same as the primary one, correct? But why this lag happens? It can happen due to a lot of reasons, like you have the heavy writes, so many writes happening, and we don't want to slow down the write operation, so we are not updating the replicas at the same time. Okay, and then there can be network delay because these machines are not same. These can be separate machines, so you have to interact with them via the network, so there can be the network delay, correct? Then you may also have like slow replica hardware, and there can be a large number of transactions, so you have to update a large number of transactions and it takes time, so there can be replication lag. Now what is the problem with this? Again the same thing. Say this is the primary database and these are the replicas, right? Say you updated some data here and then you try to read that data, you will get the stale data from the replica because there is a replication lag. The changes that you have made in the primary are not currently reflected on the replicas. So this is what we call as like eventual consistency, which means that if you try to read the data at the same time, you won't get the updated or the exact data, but after some time, after the replication lag, you will get that data. So this term is called as eventual consistency. Okay, that after the replication lag you will get that updated data, but there will be some delay, and that is called as like eventual consistency. So I hope you got this problem what we are talking about. If you update the data and if you try to read that data, you won't get that exact data at the same time as there is replication lag, correct? So you will get the stale data. So how can we fix this kind of problem? Now basically one of the solution to this problem is that you can route the critical reads to the primary. So earlier we said like in the primary we will only do the write operations and the read we will do from the replicas, right? But now as we see, there is the replication lag which can happen, which is a very common kind of issue as well. So what we can do is like if you have a critical kind of read that you detect, what you can do is like you can route that to the primary database instead of waiting for the replicas to be updated after the lag, right? So we can't wait for the lag. So then in case of the critical reads, you can route it to the primary. And then there is one more solution. You can use the cache with the write through, but let's discuss about this first one, routing the critical reads to the primary. How can we do that? Okay, so when we discussed about like how we will decide the machine through which you will do the read operation, correct? Here we said that we have three options. Okay, we said like load balancer is quite common, right? And there can be database proxy, but there is one more option, which is the application code. So basically using something like this in the application code, you can redirect to the primary machine instead of the replica. So if the read is critical, you are making it to the primary machine. Although we said that the primary machine, the role is to only handle the write operations, but if the read is critical, you can also redirect it to the primary, and because we have performed the write operation on the primary machine, it will always contain the updated information, and when you read from it, of course you will get the updated data. So if the read is critical, you will get updated data and not the stale data. But in else case, if it is not critical read, you can send it to the replica, and then further you can decide it in any of the ways, like which particular read replica you want this to pick. Okay, but this is something that we wanted to talk. Like if your read is critical, then you can basically redirect it to the primary one through the application code, right? All right, so after this, next let's talk about the failure scenarios using the read replicas. Okay, the one good thing about read replicas is that it provides you multiple read replicas. So just in case one of the machine fails, correct, so what you can do is like redirect its request to other machines, correct. So that is why it is really important in avoiding single point of failures, so that even if one machine fails, you can redirect the request to other machines, right? So it handles it in a wonderful way. So this was when one of the read replicas fails. But what about if the primary machine or your master machine fails? Then how to handle that? Okay, so in case your primary fails, okay, what you need to do is like you have to select one of the replicas. Say for example, we pick this one, okay, and we make this the primary one. So this will become the new primary. This was the old primary and this is the new primary which we took from the read replica. So now this is not acting as like the read replica machine, it is acting as the primary one. Okay, so all the routing which was happening for like the write operations, now instead of going to this, it will go to this because it is acting as the primary now. Okay, and then it will resume the write operations. These two will keep on acting as like the read replicas. So all the read operations which were earlier coming to 3 machines, now the routing will be updated. These will only go to these 2 machines, but the write operations will be redirected to this machine now, as it is acting as the master now. So in order to perform this, we can use the tools like MySQL orchestrator and much more. Okay, we covered about the read replicas. Now let's discuss about sharding. So basically sharding is kind of horizontal scaling where we would split the data horizontally across multiple databases. So you can imagine it like instead of having one huge database which has everything, we will split it into multiple smaller database which will be called as shards, right? So instead of like one huge database containing records like 1 to 1 billion users, we will have multiple smaller databases or shards, like shard 1 having the user data from 1 to 250 million, then shard 2 having 250 million to 500 million, then shard 3 having users data from 500 million to 750 million, and shard 4 having user data from 750 million to 1 billion, correct. So we have distributed it into smaller multiple databases or shards. So now we have multiple shards here, but each shard will have same schema and each shard will store subsets of rows, right? For example, it is having user data from 1 to 250 million and similarly 250 to 500 million, but every shard has the same schema and contains subset of the complete data. Now when we discuss about sharding, a basic question that may come into your mind is, why do we need sharding? Now as I said earlier, sharding is like horizontal scaling. So if you know the basics of system design which we have discussed in this video, you might be already aware why we need sharding. Like it's like the horizontal scaling of the database. Like we do horizontal scaling for our like servers, in similar way we need the horizontal scaling for our databases, right? So refer to this video where we have discussed about in detail of the fundamentals of system design. But okay, coming back to the topic, what are the problems that we face without sharding? It's like there is only single database which contains all the data, so all the load goes into it and it acts as like single point of failure. So for example, you have only one huge DB, so it can act as like single point of failure as well. But at the same time, like we discussed, we want to do vertical scaling, but then on vertical scaling you have a hardware limit. You cannot increase it after a specific point, like because this is a kind of a machine and machine has restrictions related to hardware, correct? You want to scale it vertically, but after a point you cannot scale it. So if you talk about like scaling, then you need like horizontal scaling, correct? And after a while, if you put too much load on a particular machine, then that machine will go down, okay? And because you have only this one huge data set, so if it goes down, your complete system goes down. So you need like horizontal scaling to handle this kind of load. Now what all sharding solves? It solves horizontal write scaling, storage scaling, and better isolation. We basically checked for scaling on the database, right? We saw like vertical scaling is one option, then read replicas is one option for the read operations. And when we talk about sharding, sharding is primarily used to scale write throughput, and the storage. So in summary, if I have to tell you, sharding is like, instead of having a big one database, you split it into multiple databases or shards. Read replicas was specific for scaling of the read operations, and sharding acts as like horizontal scaling for the database. So one question that may come into your mind is like, what is the difference between sharding and replication? Because we have checked about like replication earlier, and now we are talking about sharding. So what is the difference between both of these? So both of these things, sharding and replication, are used for scaling of the database. Like when things happen at a huge scale for database, how do you handle that? So both of these help in it, but let's see the key differences. The goal for replication is to scale the reads. If you have so many read operations, how do you handle that? Using replication. And the goal of sharding is to scale the writes. Okay, so replication is for scaling the reads, sharding is for scaling the writes. And when we talk about the data aspect, replication we are doing by copying the stuff, right? You basically create the replicas, so you are basically creating a copy of that. Whereas when we talk about sharding, it is happening by splitting the data. So you had this big database, you split it into small multiple databases, or the multiple shards, you can say. Next, when we talk about the consistency, in replication we have eventual consistency. Why? Because if you write in the master DB and then you have the replicas, so there will be replication lag that we discussed about, right? So these will be updated after some time or after some lag. So we will have eventual consistency. But when we talk about consistency in sharding, it will be strong per shard, because you will make a write operation to a particular shard only, right? So we have split the data into multiple shards. So your write operation will happen to a particular shard, and in that particular shard the consistency will be strong. Next, when we talk about the complexity, for replication it is medium complexity, but sharding is of like bit high complexity. How? I mean, you'll see more about sharding in this video, and you'll get to know like why sharding is bit hard, specifically when we talk about like SQL database. Okay, so sharding comes as like one of the, you can say, the weak point or difficult point to handle in SQL, because you have to handle it by your own. Whereas when we talk about NoSQL, they are automatically quite good. They are made in such way that they are good in handling like the horizontal scaling. But in SQL, you have to handle it yourself by doing the sharding. So basically the logic of sharding, the shard which to pick and how things happen, it happens on the application layer for SQL, and that is why it makes things more complex. I mean, we will talk about more later in this video, but very simple things. Say for example, you have like 4 shards for now, and your logic is that it should go to some particular shard. There can be some method that you have written based on which it can go to a particular shard, but say after a while one of the shards is down, right? So then you have to keep that logic so that it can be handled by the application logic. So there can be changes in that kind of things, right? So yeah, there is complexity in sharding. We'll discuss more about sharding, the logic, all the things. We'll also discuss the aspects like SQL versus NoSQL. Why is it so typical for SQL, whereas for NoSQL it is kind of automatic thing, the horizontal scaling. Now, as we said, like there are multiple shards now, and we saw that it can be something like shard 1 contains data for 1 to 250 million, and shard 3 contains for 500 to 750 million. Like, but how do we know where the data exists? And that basically happens using the shard key. So the shard key basically decides where the data exists. Okay, so if we have the bad shard key, then it can result in hot shards, imbalance, and lot of issues. Okay, and good shard key would be where you have like evenly kind of distribution among the shards. Now I understand the basic questions in mind would be related to the shard key and what are the strategies used for sharding. So let's discuss both of these in detail. So the first type is range based sharding. So it would be something like we saw in earlier example also. So user ID from 1 to 100k we would put in shard 1, and user ID from 100k to 200k we would put in shard 2. So we have decided the range, this range, so this shard. Okay, like that we can basically distribute. It appears to be simple, so that is a pro. But the con part would be like a particular user or set of users in a shard can be hot shards. So many write operations happening in particular shard whereas in shard2 there might be like a very light load kind of a place, right? So there can be hot shards that can be formed due to the con of this range based sharding. So this kind of approach can be used for like time based data or logs, you can say, because that would come into particular range. All right, the second type is hash based sharding, which is the most common. Okay, so instead of just deciding the range, what we are going to do is like make a hash related function. Like for example, if there are n shards, so we would do whatever user ID comes modulus n. Okay, this is just a method that we made. You can have of course a better hashing related method. Okay, and based on that we will decide the shard. So the pro of that is like we have like even distribution and no hot shards happening here. So in first case, hot shard can appear, say for example, you made like shard1 for 1 to 100k user IDs, and there were user IDs mostly lying in that range only. So you would have a hot shard as shard1 because in shard2 nothing is coming. Whereas when we talk about like the hash base, it will evenly distribute among all the shards. Okay, so there would be no hot shards in this. But of course, like range queries were easy in the first one because it was range based. Here it would be a bit difficult for the range queries. And if you do simple like this kind of function where you are just doing the modulus on the number of shards, if you add a new shard, then it will become difficult because this all calculation will become difficult now. So there will be a lot of changes happening on based on that. But the best part of hash based sharding is that it is evenly distributed. All right, the third type is directory based sharding. In this you have maintained a lookup table, and corresponding to the user ID you will have the shard ID maintained. So you are maintaining an additional memory here. Extra lookup is a con that would be part here. Okay, but the most common of course is the hash based sharding, where you use the hashing approach to identify the shard. Okay, so let me explain it to you with a very simple example. So say we have this users table. In the users table you have like columns like user ID, name, email. Now which column should we pick as the shard key? We discussed like shard key is very important because based on that we will decide our shard, correct? And it's important for you that you pick up like right shard key, otherwise it can create a lot of issues for you like hot shard and many other imbalances, correct? So here if you see these, which one would you pick as your shard key? User ID, right? So if we pick the shard key as user ID here, then basically we will decide the shard based on this user ID. So we will use this hash based sharding approach because this is the most common. So we will use this only. Okay, so what we are going to do is like put it in the hash function where we will pick the user ID and we will do the modulus of 4. Okay, so say 4 is the total number of shards, so we will do modulus of 4, and based on that we'll get the shard. Say for example the user ID was 101, so it will do 101 modulus 4 and it will return you 1. So shard 1 is the answer for this user ID 101. Similarly, if the user ID is 202, so we will do 202 modulus 4, which will give you 2. So it will send you to shard 2, right? So using this you will be able to identify your shard. Now as we know, like we have multiple shards, right? So we have split the big database into multiple parts, correct? So how will the querying happen in this sharding system, right? So that's the main question, how the querying happens in the sharded system. Let's try to understand that. So we identified above that everything is dependent on the shard key, correct? Based on the shard key you will be able to identify your shard. So here also when we talk about querying, there are two cases. First, if you are querying using the shard key, so if you are doing this, then it will be fast because you are using the shard key. Now why it will be fast? Because you will make a query something like this: select star from users where user ID equal to 101 and user ID was our shard key, correct? You remember this? Our shard key was user ID. So basically we are querying with the shard key, and based on the shard key you will get to know your shard, correct? For example, here we identified using the hash function and we will get the shard. So for example in the query you had like 101, so you will get the shard from this like 101 modulus 4, so it will return you 1. So shard 1 is your place, so you will hit only one shard, correct, and you will be directly routed to your particular shard. So that is why this is very fast, because everything is dependent on the shard key, and here you are querying with the shard key only. Now the second case is query without the shard key, and that would be really expensive. Let's see an example for the same. So here is the example. We are doing select star from users where email equal to this, okay, and email is not our shard key. Our shard key was user ID, correct? So that is why it will become quite expensive, because it will be difficult for you first of all to identify which shard to query on, correct? You have multiple shards now, you have split the data into multiple shards, and if you would query based on the shard key, you would clearly know which shard to go on, and that's why your routing will be quite easy. You will just hit only one shard. But when you talk about like you have not included the shard key here, then first of all it's difficult for you to identify which shard to go on, okay? So it may result in that you have to query all the shards. Depends on what strategy you are using, but the worst case would be like you have to go to each of the shard and try to identify whether you find out your thing here or not. So there can be high latency in this case. So basic thing to remember when we talk about sharded systems, queries without the shard key are quite expensive. Now a question may appear like, how will we handle this kind of scenario where we have made a query without the shard key? I mean, it depends. The worst case is like, of course, you can go to each of the shard and try to find out. That would be the worst case scenario. But you could also do some optimizations on top of it. For example, you have maintained the mapping. So there is additional kind of mapping that you have maintained, or additional index service that you have maintained, through which what you want to get is like, through that you get the mapping from email to the user ID. So once you get the user ID from that mapping, from the email, then you simply can find out the shard, because your user ID is the shard key. So instead of searching the user directly via email, what you are trying to do is like, you can basically try to find out the user ID from the email from some other mapping that you have maintained, okay, and then from the user ID you'll get the shard, and you say get to know this is the shard, you directly go there and you find out, okay? So this kind of optimizations you can make, but of course the worst case you have to go through all of the shards if you're not doing any such optimizations on top, right? But of course this is expensive. Even if you have made some optimizations, you have to do that additional step, right? So if you're not doing the query on the shard key for the sharded systems, it will be expensive. So like we had the pain for querying without the shard key, another pain point could be if you have to do cross shard join, right? We discussed about joins where you have to find out the data from different tables, correct? And in sharding you are basically splitting out the data into multiple tables, right? So there might be a situation that you have to find out the data from shard 1 and then shard 2 as well, and then join that data. So that can be also quite painful, because you have to make multiple DB calls. There will be high latency and there can be complex failure scenarios in it. How this can happen, like for example, you have one user shard, right? And you might also have like orders shard. Both of these can be different, and in a query you might need data for both. So it's kind of like cross shard join, yeah. So we are doing cross shard and then join on top of it, because data is present in different shards. So for that, what you can do is like, you can co-locate the related data. If some data is related, you can co-locate that. Another thing that you can think of is the denormalization, because joins you are using because of normalization, because you have split out data, and here you have different shards. So maybe denormalization can help. Of course, you can clearly see that cross shard transactions will be quite slow. Okay, all right, let's move to another topic related to sharding, and that is re-sharding. Now what is re-sharding? Now we said like we split a big table into small shards, right? So say these are your shards, but now some case can appear that this shard, okay, becomes too big, or it has too much traffic to handle. Then what to do? Then we have to do re-sharding, right? Because now this particular shard is too big and we need to shard it further. So what will be the problems in re-sharding? There will be data movement, there will be the risk of downtime, and there will be cache invalidation, because you are re-sharding it So basically you are splitting it further into small shards, so you will have to face all these problems. Now what are the solutions? Consistent hashing is one thing that can really help. If you want to know about consistent hashing, put that in comment section. I'll create a separate video on that part. Then we can have the virtual shards and online migration. Okay, I think we don't need to go in much of detail of this. It was just to share this topic, re-sharding. So let's move to the next point from here. All right, now that we are talking about sharding, let's also discuss about one of the famous problem that we face in sharding, which is hot shard problem. Let's try to understand it with a very basic example. Say you have done the sharding basis on country. Okay, so in the India based shard, you may get massive traffic, right? Whereas the shard Nepal might have like small traffic, right? So the basic problem is like one of the shards gets too much traffic, right? So that's why it's called like hot shard. All of the requests are coming to this particular shard, whereas other shard, it's like very less kind of traffic happening. So this kind of a problem can happen in sharding. Now let's see what can we do for that. All right, the fix is first hash based sharding. We discussed about what is hash based sharding. We discussed like range based sharding, hash based sharding, and directory based sharding. And we said like hash based sharding is most common because it gives you distributed kind of load, correct? So it will fix the hot shard problem. And then we need to pick the shard key in the correct way. It's important that you pick the right shard key, and we can also have like composite kind of shard key, so that will help to resolve this hot shard problem. Okay, one more thing about sharding, like we discussed like about the concepts like sharding and the replication. We also saw what is the difference between sharding and replication. Now in real world, what happens? So basically in real world we use both. We use replication as well as sharding. So it's a combination of both of things, because replication is used for scaling your reads, whereas sharding is used for scaling your writes. So you will have multiple shards, and each shard has replicas. Okay, so each of the shard will have like primary and the replicas. So we are doing the combination of sharding and replication, multiple shards as well, and each of the shard has the replicas as well. So due to this, we have the high availability and high scaling. Of course, we are doing sharding for write scaling, and then for each shard we are doing the replicas, so read scaling is also there. So we discussed about sharding, but now let's discuss in terms of SQL. Okay, so we discussed like sharding, what is sharding, how do we do it, what does it mean. But now let's talk in terms of SQL or RDBMS database. Okay, so we discussed in SQL we follow the ACID properties. So it is good for consistency because it follows the ACID properties, right? So for financial transactions, for banking apps, you use the SQL because of its consistency and all the ACID properties it provides, correct? And in SQL we follow like normalization, correct? So we normalize, that means we create different tables based on the role, you can say, and that helps in maintaining the consistency, correct? And then we use joins in SQL. So SQL is good for joins because it follows like normalization, and of course you need to get the data across multiple tables, right? So you would need joins for it. Okay, now the point comes for huge scale, correct? When we talk about scale, we discussed about like we can do vertical scaling, but you cannot do vertical scaling after a point, correct? Then we talked about replications. You can create multiple replicas, and of course that is good for your read scaling, read related scaling. You can do the replication. But then comes like the write operation related scaling, and for that you need to do the sharding. Sharding acts like the horizontal scaling. So the point is, in SQL the horizontal scaling or the sharding is a bit complicated or difficult to do. You have to manage it. It's complex. But why? Let's understand why is it difficult in SQL to do like horizontal scaling or sharding. Why is it so complex? All right, let's understand that. Yes, of course you can do the horizontal scaling in SQL, but it is complicated. Why? Because first, sharding breaks the joins. We said like we'll follow the normalization in SQL, and SQL is also good for joins. But when we split into multiple shards, right, so the joins becomes quite difficult. Why? Because now you have to do joins across the shards. Okay, you have to do joins across shards, and that are really expensive, and those are really difficult. Okay, so it becomes hard. So the transactions also become hard because you need to maintain the ACID properties, that is the core of SQL. You need to maintain the asset properties. But when you have to maintain asset properties across the shards, it's very complex. Okay. Third point is related to operational complexity. Now, the important thing to understand here is like the sharding or the horizontal scaling for SQL, it is not automatic. It is kind of managed by you. This is like app-based logic. Okay, so your app logic is there which makes this sharding happen. But the problem with it is like re-sharding requires data movement that we saw. Like re-sharding is the thing, like you have to do the sharding again because your particular shard is becoming like huge. Again, you have to do re-sharding on top of it. So that has its own set of complexities. But another problem is like because you are doing the sharding using your app-based logic. So app logic has to handle a lot of things, and due to it, it becomes like complex. App logic must know the sharding mapping as well. When we talk about NoSQL, you'll get to know that in NoSQL, the horizontal scaling is kind of automatic. NoSQL database is built like that it doesn't need to do the horizontal scaling based on the app logic. It happens at like the DB level, you can say. I'll explain it to you when we talk about the NoSQL. But for now, you need to understand in SQL, it is not kind of automatic thing. Your app logic defines the sharding. So it becomes quite complicated. Like for example, a new shard added or a shard removed, then all that kind of things are handled by the app logic, correct? Whereas when we talk about NoSQL, which we will talk later, it handles that automatically at the DB level. So because in SQL it is handled at the app logic, it is complicated. Okay, and then it has other things as well, like for example, there is limited flexibility. If you have to change the shard key, it is quite painful. So the sharding or the horizontal scaling in SQL is quite painful because it is handled by the application logic. The sharding at SQL is handled at the application layer. So for now, you need to remember this. SQL, the sharding logic would be at the app level. Okay, I'm writing app here. Whereas when we talk about NoSQL DB, so in NoSQL DB, it will be handled at the DB layer. Okay, so that is automatic and it is quite easier as compared to in SQL. So in SQL, the horizontal scaling becomes like a difficult thing or a complex thing to handle. Okay, that is why when we talk about huge scale, then sometimes we give preference to NoSQL. When we don't rely properly on asset properties, when we don't need like asset properties too much, then if we are talking about huge scale, then we prefer NoSQL. Okay, don't worry, we'll discuss more about it. I mean, this part also, as app based logic and DB based logic, we'll discuss it again when we talk about the NoSQL part, so that you get more clarity. But for now, just remember, SQL is good for asset properties, consistency. It would be used for like financial related transactions, for banking apps. It is good in normalization. It is good in joins because SQL is basically relational database. So maintaining relation between multiple tables using the keys, it's about SQL. Joins is good in SQL, but problem comes when we talk about horizontal scaling or scaling the writes or using the sharding, because across shard, when you have to do joins and maintain the asset properties, it becomes really complex. And overall, the sharding is not automatic in SQL. This is happening at the application layer logic, and that is complex to handle. Okay, all right, so this was about SQL. All right, before moving to NoSQL database, one more important doubt that I want to discuss, because maybe you have a similar doubt in mind. Okay, the doubt is, in normalization, joins are fine, right? In normalization also we split the table, and in that joins are totally fine when we talk about SQL database. Then why join is the issue in sharding? In sharding also we are kind of splitting the tables. Then why join is difficult in sharding, whereas it was fine in normalization? Joins are really difficult. But why? How is it different from normalization? Let's try to understand that. Okay, so here is the fundamental difference. In normalization, we split the data, but that is only logically. But when we talk about sharding, we split the data physically. Now let's try to understand this with an example. Okay, so here you see the example of normalization first. We have normalized the table. So now we have two tables, users tables and the orders table. Okay, these have like separate columns. Basically, instead of having all the data in one table, we have normalized the tables into two different tables, users tables and the orders tables. correct? So the important things to remember in normalization is that both the tables are in the same database. These are also on the same machine, and these are under one query engine. Okay, so that means it's not like physical separation. These are just logically separated. Okay, but both of these tables are on the same machine in the same database, so they are part of same query engine. So that's why join is easy here. We can simply do something like this: select star from, this is the left table users, and we do the, say, any type of join here on the right table, and we provide the condition using the on keyword, right? So say for example we are doing the inner join of both of these tables based on this condition. The important part to remember, both of these tables are on the same machine in the same database and under same query engine. So database can read both tables, use indexes, and join row by row efficiently. So that's why normalization is just logical separation, nothing else. So that's why join is easy in normalization. Now let's take an example of sharding through which you will get more clarity. So sharding says this data is too big for one machine. Let's split it across multiple machines. So clearly you can see we are talking about the physical separation. That's why it's also called like horizontal scaling, where we talk about different machines, right? So like in normalization we took the example, correct, like this users table and the orders table. Now let's see similar for sharding. You can see this is the shard 1, which you can take as machine A, and this is shard 2, which is machine B. So two different machines, right? And in machine A we have data of users Rahul and Neha, whereas on machine B we have data of users Amit and Priya. So clearly you can see the users table is now split physically in different machines, because the data might be too big for one machine to handle, correct? For example's sake we took like 2 entries here, but you can imagine there can be a lot of entries. That's why we did the sharding. We need multiple machines to handle that kind of data, correct? So this was about the users table like we saw here. Similarly for orders table we may need to do the sharding. So machine A will have orders like this, and machine B will have some other orders like this. Okay, so this order is for user 1 and this order is for user 3, correct? But clearly you can see these are on different machines now. Now let's see why joins are so hard in sharding. Say for example we apply this query, select star from, this is the left table, then we apply say inner join on the right table, and we provide the match condition using the on keyword, right? So this is your join query. But now as we saw, the data is present in different machines, right? So now database has to do a lot of things. It has to query machine A, it has to query machine B, and it has to move data across network. Why network? Because these are now two different machines. Data is not present in a single machine. These are two different machines. So in order to connect, you would require the network, which is slow, correct? And then you have to merge the results. Then you have to handle the failures. You have to handle the timeouts. So this is not anymore a normal join, correct? We saw in case of normalization we were able to do the simple join because both of the tables were present in the same database in the same machine, so it was quite easy to do that. But now we are talking about different machines in sharding, and that's why it's not a normal join, it becomes a distributed join. Why distributed? Because there are different machines, correct? Now the distributed joins are very slow, very complex, and very failure prone, and that's why databases avoid joins across the shards. So in SQL we earlier said that normalization is totally fine because we are splitting the data just logically, and SQL is good in joins, correct? Because it is like relation between different tables using the keys, and SQL is good in it. But when we talk about sharding, first of all, sharding is complex in SQL because that logic needs to be handled by the application layer, right? And on top of it, the joins become very difficult because it is no more the normal join, it is a distributed join now, because now the tables are split physically. So there are different machines which have this data, so you have to connect the data from different machines. That requires network, and there are a lot of complexities involved, and that's why it becomes so hard to manage or to handle the joins in sharding, because it's a distributed join now. And as we are talking about SQL first, in SQL the main property it follows is consistency, and it follows the ACID properties, correct? And it becomes really difficult to maintain the ACID properties across the different machines. So when we are doing sharding and we are doing the distributed joins, it becomes really difficult to maintain the consistency of the data, and it becomes really difficult to maintain the ACID properties across the shards. That's why sharding is a quite complex thing in SQL. So in summary, as we were talking about normalization and sharding, normalization is logical split, whereas sharding is physical split of data. What does that mean? In normalization, you have the tables on the same machine, whereas when we talk about sharding, we have data on different machines. Like we saw the case here, right? The users table, some of the data is present in machine A and some of the data is present in machine B. Similar can be for the orders table as well, right? So in sharding, you have different machines. In normalization, the data is under same database engine, whereas in sharding, you would have multiple database instances. So when we talk about join in normalization, join is local, whereas in sharding, join needs network, because we have different machines, and when you have to interact between different machines, of course you would have to require the network. When it's in the same machine, you can do that locally. So there is no need of network calls in a single machine, correct? So that's why normalization is fast and safe, whereas sharding is slow, risky, and quite complex. So basically, in normalization, generally you say you have a different table, but when we talk about sharding, it is not that simple. Different machines are involved. Also, there will be multiple database instances involved in sharding, and because there are multiple machines, so you would have to interact between the machines using the network. And there would be other complex things, like there would be no global lock, because it's easy to make a global lock on a single machine, but when you talk about different machines, you can't have a same global lock across them. So a shard is like a complete database which is present on a different machine. So in real life, simple examples if I have to tell, when you say you have a flat like a 3 BHK, correct, in a society, so that would be an example of normalization, because you have 3 rooms out here, correct? So 3 bedrooms you can say with washroom. So different you can say rooms, but all of these rooms are part of same flat, correct? So one flat, but you have 3 different rooms. Similar to that, in normalization, you have different tables, but those are present on the same machine under the same database. But when we talk about sharding, it can be like one room is present in one city, like it is present in Mumbai, and another room is present in say Delhi, and one more room is present say in Bangalore. Okay, so different cities. So in normalization, because these are part of the same flat, so you can directly move from one room to another room. But here, if you have to go from one room to another room, then you would have to take flights, correct? You can't just like move from one room to another directly, because these are in the different cities. So you'll take the flights or any mode of transportation to reach there, so that this would be complicated. Similarly, when we talk about sharding in actual terms, so it would be kind of different machines are involved. Okay, so you can't interact with them directly, so you would require the network or API calls to interact between each other. And when we say like why SQL avoids DB level sharding, because SQL database are built around the properties like single node ACID properties, because it follows the ACID properties. Strong consistency is another thing that SQL database follow, and it is good in local joins like in normalization. But if we do the automatic sharding, then it would break the ACID properties. But SQL is major for following the ACID properties. If we do the automatic sharding like normally we do in NoSQL, then it would break the ACID properties across the shards. It would also break the joins. It would break the transactions, because we were following or using the SQL database for these two important things, following the ACID properties and strong consistency. But automatic sharding would break all of these. So that's why in SQL, If you shard, it is managed by the application. So the application layer is managing the sharding logic, and that is a bit complicated or complex to handle. So in SQL, you have app level sharding and not DB level sharding. Okay. Now you may say why I'm using this term like DB level sharding. This is because in NoSQL, there is DB level sharding which is automatic, and that is not handled at the app level. Don't worry about it. You'll get more idea as we discuss about NoSQL database. But just to give you the brief summary, NoSQL handles this thing in a better way because in NoSQL, we assume that joins are bad. The SQL database is good in joins, so we do perform the join operations in SQL, but NoSQL, it assumes joins are bad and it encourage denormalization. In SQL, we encourage the normalization, right? We split the tables logically, whereas in NoSQL, it encourages denormalization, which means all of the data would be present in one place. So that's why it stores everything, whatever is needed together. So this is an example of NoSQL. You can see it contains like the user ID, name, and also the orders related information. So the data related to user and the orders, both of these are present in one place because it encourages denormalization. And because we have all the data in one place, so as there is no need of join, there would be no need to do the cross shard fetching as well, and you can get all the data in one read from one machine only. And that is why on NoSQL, the horizontal scaling is very good. Okay, and that is done automatically at the DB level, not at the app level, at the DB level. But don't worry about all of this. I just gave you the brief summary. Now basically what we will do is like try to understand about the NoSQL database, what are different types and what are the properties which are present in NoSQL database, through which you'll get the more clarity about it. Okay, so let's move to NoSQL databases. All right, the first question that comes in mind is, what is NoSQL? So in very simple terms, NoSQL is not only SQL or not only SQL. We discussed about SQL database or the RDBMS database, where it used to follow the properties like strong consistency, follow the ACID properties. It was good in normalization and doing the join operations. Now we are talking about NoSQL. So NoSQL databases are designed for massive scale. So SQL is not that great when we talk about massive scale. Why? Because we saw sharding or horizontal scaling is quite complex and difficult in SQL database. But when we talk about NoSQL database, it is designed for massive scale because horizontal scaling is not an issue in NoSQL. It is done automatically at the DB level. So apart from that, NoSQL is designed for distributed systems, right? High availability and flexible schema. Okay, flexible schema is another important point to notice here. In SQL, we had like fixed schema, correct? So SQL is good when you have like fixed schema. But there can be also the cases when you have like flexible schema, and for that we have the NoSQL. So unlike SQL or RDBMS, NoSQL systems assume that there can be node failures, there can be partial data availability, and there can be network failures. Now a basic question that comes in mind is, why NoSQL exists? Basically, NoSQL solves some of the difficulties or issues that were faced in SQL database, like horizontal scaling, which is quite difficult in RDBMS because we saw that sharding is quite complex in SQL database. We cannot do automatic sharding, and that's why it needs to be handled at the app level logic, which becomes complex, right? So it is hard in RDBMS, but in NoSQL, it is built in. How? Because the horizontal scaling or the sharding, you can say, in NoSQL is done at the DB level. It is done automatically because all of the data that is required will be generally stored together. So we don't face the problem that we face in SQL, like some of the data in one machine, some of the data in another machine, and you have to use the distributed joins to get the complete data. So that is complex thing in SQL, but in NoSQL, horizontal scaling is kind of the built-in or automatic feature which is handled at the DB level. Next, when we talk about the schema changes, RDBMS, it is quite painful because in RDBMS or SQL, we have generally the fixed schema, Whereas when we talk about NoSQL, it has like flexible schema, so it is very easy to make any schema related changes. Next, when we talk about a point, say there are a lot of write operations happening. So in RDBMS, we have kind of limited scope for that, but in NoSQL, we have high throughput. So in case we have massive writes, NoSQL is generally better in handling that case, because again, as we discussed earlier, you knew that when we had to scale the read operations, we use the replicas in SQL. But when we talked about scaling the writes, we required sharding, and hence it becomes difficult, right? Whereas in NoSQL, it is known to handle massive writes, okay? And when we talk about the global distribution, of course, in RDBMS or SQL, it is complex, whereas in NoSQL, it is kind of a native thing. So NoSQL handles all these things related to huge scale, a lot of write operations, schema changes, and global distribution in much better way. But you may say, how is this possible? It's very simple thing, like SQL follows some of the principles like strong consistency and following ACID properties. So it is really good in that. Whereas NoSQL, it would basically perform all these things as a trade-off. So the NoSQL is not good in strong consistency, okay? And it is not that good when we talk about following the ACID properties across the machines. So it would trade off such things for providing all these features. All right, so now that we have mentioned consistency point here, so let's discuss a very important concept which is very frequently asked in interviews, and that is CAP theorem. So the first question comes is, what is CAP theorem? So basically in CAP, C stands for consistency, A stands for availability, and P stands for partition tolerance. Now the important part to understand here is, in the distributed systems, you can only guarantee 2 out of these 3 things, which means you can either have CA or you can have AP, okay, or you can have CP, but you cannot have all 3 of these. CAP is not possible when you talk about the distributed systems. You can only guarantee 2 of these, so only these combination can exist, CA, AP or CP. But now, because we are talking about the distributed systems, so this P part is required, which is the partial tolerance, okay? So this one, CA, this is not possible because we are talking about distributed system, and P is mandatory in it. So you have choice between AP or CP, that is, you can either provide availability and partition tolerance or consistency with partition tolerance. I know you would have questions in your mind, so let me tell you what each of these mean actually, and through that you'll get more clarity, and we'll discuss some of the queries through which you'll get some more understanding, okay? So first, let's try to understand the meaning of each of these. First, when we talk about consistency, it would mean that every read returns the latest write. It means that whenever you perform the read operation, it should return you the latest kind of data which is present in the database. Or if it cannot return you the latest or most updated data, it will throw you an error. It cannot provide you the old data, okay? So this consistency might confuse you with the ACID properties which we discussed in SQL, but this is different from that, okay? You need to keep that in mind. In ACID properties, C was like more about like the constraints for the consistency check that you can apply, something like the money in bank should be greater than 0 before you can make a transfer, right? Or you apply the constraints like the not null or unique or any key related constraint, all such kind of things that you need to apply. But here consistency means, say in database, okay, you had value of something like say I, earlier it was say 10, okay, and someone made a write operation here and updated it to say 12, okay? So the point of consistency here is, if someone makes a read operation here, you need to return this updated value. You cannot return this old or stale data. You have to return the most updated thing, or just in case you cannot, you have to return an error. So that is what consistency stands here for. That if like all the people are getting like same kind of consistent data, whatever changes you made, you're getting the latest data. Similarly, someone else is checking or reading the database, they should get the same data. Of course, it looks quite simple when you talk about single machine, but because we are talking about distributed systems, so you understand we have multiple right, machines in which data is present. We talked about like different architectures like master slave in SQL, correct, where you would make the changes or write operations in the master or the primary, but you would read from the slaves or the replicas, correct. So of course we also talked like if you update the replicas, then your write operation becomes slow because you have to wait for all the replicas to be updated, correct. But if you just write in the database and you don't update the replica at that time, then the consistency can suffer, correct, because you are reading from the replicas, not from the primary database. So in that kind of scenario, you might return the stale data or the old data, like 10 might be returned, but we don't want that. When we talk about strong consistency, it means either you return the most updated or the latest value, or you simply return an error. Okay, so this is the meaning of strong consistency here. Next term is availability, which means your system should be available. Like for example, this is your system, or you can say database. So any request which comes to your system, it can be anytime, because your system is distributed and it might be serving the request from all over the world, correct. So we have different time zones, so you may get the request anytime, so you need to be available 24/7. So every request that comes, it should get a proper response. There should not be any error in that part, correct. So your systems cannot go down, and your systems cannot be like it is crashed, it is not giving response, or it is giving just errors. It has to give the proper response, correct. And the third one is the partition tolerance. So partition tolerance means system continues to operate despite network failures. So in easy terms, you can make it or understand it like there is no single point of failure, so that even if one of the machine goes down, your system as a whole unit should perform. How do you do that? You have like multiple machines out there, you do the horizontal scaling, or you have like partitions, like through which even if there are some failures, your system as a whole unit should be able to operate. It's not like if one machine is down, your complete system goes down. No, that is single point of failure. You have to avoid that, because we are talking about the distributed systems. So you will have different set of machines which can handle the failures. So if one machine is down, you have to distribute the load across other different machines so that the users can still get the data, correct. So now why we said like CA is not possible, because we are talking about the distributed systems. So P, or the partition tolerance, is a required or a must thing, correct. Otherwise we won't have the distributed system set up, because we are talking about distributed system. So in CAP, we either can provide consistency with partition tolerance or availability with partition tolerance, because P is mandatory as we are talking about distributed systems. But now the question comes, why we are saying we can guarantee only two of these? Why can't we have all three of these, like consistency, availability, and partition tolerance? So let's try to understand that with an example. Okay, say we have like two nodes, right? We have node A and node B. So this is like, you can say, the partition that we have, like different nodes out there. Now we will see the two scenarios here. Okay, the option one, first we are focusing on consistency. We said like there are three things: consistency, availability, and partition, correct. So partition is always there because we are talking about the distributed system. You can also see here we have multiple nodes here, correct. First we'll focus on the consistency, and we'll try to have the availability as well, and we will see why we cannot have all three of these together. Okay, so we'll first focus on consistency. So consistency and partition, correct. So what happened here is like we made the change on node A, like we saw the earlier example. I was say 10. Okay, the value of 10 was present on both of the nodes, node A and node B, and now someone changed the value of I to 12. So node A has value 12, whereas node B has value 10 right now, because the write operation we performed only on node A, and it did not wait for updating all of the other nodes, because it would become very slow, correct. So in this case, in case a request comes to node B, right? Now what strong consistency means? Strong consistency means either it will give you the most updated data, which is 12, but it cannot give you that because it has the old data right now, it has the stale data. So there were only two things: either it will give you the most updated data, or it will return error. Now because node B cannot return you the most latest data because it has not synced with node A yet. So what strong consistency means, if it cannot give the latest data, it will give an error, correct? So the node B will reject the read request or it will give the error. But if this is done, then the availability is sacrificed. Why? Because availability meant that every request receives a non-error response, but we are throwing an error here because we are following consistency. So that is why here you can see we cannot follow all three of the properties, right? We are following just C and P, consistency and partition tolerance. Now what is the second option? The second option is following availability with the partition tolerance. So in the same example, if the read request comes on node B, then because we are following availability here, so node B will serve the old data, that is it will return, say for example, the value as 10 instead of 12, which is the old or stale data. Now because it has returned to the response, we are good with the availability because we have not thrown an error here. But we have sacrificed the consistency because we have not provided the latest data, we have provided the old data, so we are not following consistency here. So that is why here the availability factor was done, but we have broken the consistency. So we are following only availability with partition tolerance and we are not including consistency here. So clearly you can see in both of these cases we are able to follow only two of the things. Either we are doing consistency with partition tolerance or availability with partition tolerance. We cannot do all three of these together. So basically when we talk about the distributed systems, you cannot do all three of these together. Like consistency, you require the latest data, right? But at the same time, availability means you give the non-error or proper response to all of the requests. So both of these cannot work together when we talk about the distributed systems, correct? So we saw both of these options. So either you have to choose between consistency with partition or availability with partition, because you cannot serve the latest data to all the requests which are coming. You would either follow consistency where you will provide the latest data or throw an error, but when you throw an error, it impacts the availability. Whereas if you give the data to all of the requests, then you might also give some of the old data to some of the requests. In that case, consistency is impacted. And this is the scenario when we are talking about distributed systems, correct? Because we are including the partition tolerance in it, right? So when we talk about distributed system, the CAP theorem says you can only guarantee two of these, okay? And when we talk about two of these, CA is not possible because partition is a required factor in distributed systems. So either AP or CP. Now a basic question that may come into your mind for CAP theorem is CAP theorem applicable to SQL database? The answer is yes, if the SQL database is distributed. In CAP theorem, we talk about the distributed system, correct? So we mentioned distributed systems here. So in SQL, if you have like distributed system, you have replicas out there, different nodes are present out there, then CAP theorem would be applicable to it as well. Which means if you talk about distributed system in SQL, you can provide like either CP or AP. Same is the case for NoSQL. So even in distributed SQL, it's a choice between CP or AP. But generally when we talk about like SQL systems, strong consistency is preferred. So generally it would give more preference to CP instead of AP. Now another common question that appears in the mind is, can we decide for CP versus AP per request that we make? So basically the answer of that is a modern concept which is like the tunable consistency, which means like some systems let you choose this, like what you want to choose, how much preference you want to give per request as well. For example, the Cassandra database, which is like NoSQL database, which we will discuss later, like because we are going to discuss more about the NoSQL database. In that basically you can decide how much consistency you want or how much availability you accept, okay? So it's kind of like per request you can choose some of these dynamics. So it's kind of like on runtime you are deciding what preference you want to give. Okay. Alright, so before we talk about the types of NoSQL databases, let's discuss few of the things that we mentioned earlier. Like we said, horizontal scaling is built in NoSQL, and massive writes is easier to handle in NoSQL. Why is that? So let's discuss about that in detail first. Okay, the first question, how is horizontal scaling built in NoSQL? We earlier discussed like it is difficult to do horizontal scaling or sharding in the SQL database, but how is it built in NoSQL? So basically the NoSQL database is designed for distributed systems from day one. The basic design of NoSQL is according to that fact only. So when we talk about scaling in RDBMS, the basic thing comes up is the scale up or the vertical scaling, which means you would look for bigger machines. Why do we say that? Because sharding is painful and manual process in SQL. When we talk about sharding in SQL, it has to be done at application layer. We discussed about that earlier, right? But when we talk about NoSQL, it is designed for distributed systems. So you can scale out or you can do the horizontal scaling very easily. It's just you have to add the nodes in it. And why is that possible? Because sharding is automatic in NoSQL database. Because that is handled at the database level, sharding is done in NoSQL database, not at the application layer. So in NoSQL database, partitioning is the core feature. So basically in NoSQL, you have like nodes, okay? So we have multiple nodes in NoSQL, as partition is the basic or the core feature of NoSQL database. Like for example, we have calculated the partition here using the partition key. Like the user ID can act as a partition key. It depends like what kind of partition key are you deciding. But the main point is every record will know which node it belongs to, say this one, and which replicas store it. Now we will have the replicas just like SQL, because the replicas were there for scaling the read operations, and we would require that in NoSQL as well. Another important part of the NoSQL is that each of the node will have its own CPU, on disk and on memory. So in this case, there are no central bottlenecks and there is no master for writes. Now another important part to remember here is that we use consistent hashing here to identify the partition. Okay, all of the nodes are basically part of this circle, you can say, and through consistent hashing all the nodes are part of this ring, you can say, and we will use the consistent hashing approach to identify the node. Now if you want to know in detail about consistent hashing technique, put that in the comment section. I'll create a separate video on that part. But if I have to tell you in summary, so consistent hashing is really helpful when you have to add or remove a node, because if you use the simple hashing technique, it would be something like your partition key and you will do the modulus with the number of nodes. Okay, say earlier the number of nodes were 4. Okay, so your hashing method will be something like this. This is your key and you do modulus with the number of nodes. Now say you increase the number of node by 1. Okay, so your method will update. So instead of 4, now you will take the modulus with 5, and due to this most of the values will get changed. Okay, so there will be a lot of change that would be happening because you have added or removed any of the node. Like removing of the node is also very common thing, because one of the system or your node can go down due to any particular reason, correct? And due to that your hashing method would change, and all the outputs that you generated for the node, that would also change, correct? So in hashing you will see a lot of changes happening when you add or remove the node. So in order to handle that, you have the technique like consistent hashing, where if a particular node goes down or you add a new node, there will be very minimal changes that would be happening, because all the nodes are present in a ring format. Okay, so this technique of consistent hashing is really helpful in evenly distributing the load, and at the same time it has very minimal impact if you add or remove a node. So going back to the main question, so basically as you store all of the related data in one place only in NoSQL, and then you have your horizontal scaling happening at the DB level and not at the application level. You have partitioning as a basic feature. We saw like there are multiple nodes, each of the node has its own like CPU and memory, so we are not sharing all the resources out here. And the techniques like consistent hashing, overall that is why horizontal scaling is built in the NoSQL database. Now because we have mentioned node and partition, the very basic questions that may come to your mind is what is a node and what is a partition in NoSQL. So basically when we talk about SQL database, we think about the tables, rows, primary keys, foreign keys, then we have joins, and then we think it as one big database because sharding or horizontal scaling is difficult to manage, or it is complex in the SQL database, correct? So SQL was like structured data in tables, and tables can connect with each other or have relations using the key, correct? And then we have joins in it, right? But when we talk about NoSQL database, we would think about keys, partition, node, cluster, and no joins. Because NoSQL doesn't believe in joins, we want to keep all the related data together, so there is no requirement of join here. So basically a node in NoSQL would represent one machine or one database instance which is running NoSQL. So a node can be represented as your laptop, a server, or a virtual machine. So one machine or a database instance which is running NoSQL. So we can represent it as like node 1 machine A, node 2 machine B, node 3 machine C. So each of the node is representing a different machine, and together they form a cluster. And as we discussed earlier, each of the node will have its own CPU, own disk, and own memory. Now that we have mentioned that node is basically representing a machine, why do we need multiple nodes? It's very simple. One machine cannot handle the complete load. As the number of users increase, you would need to scale. And one of the format is horizontal scaling, correct? So you would require multiple machines, so you would require multiple nodes. And also when we talk about the distributed systems in system design, we have to avoid single point of failure. If there is only one machine, then of course there is a single point of failure, and we need to avoid that. So we would require multiple nodes. Now when we talk about partition, partition is a piece of data. It's not a table, it's not a machine. It's just a logical slice of data, you can say. So if I have to give you a real life example for partition, it would be, think of a big book, okay? Now instead of one huge book, we want chapters in it. It makes things easier for you. So partition is like chapters. You are doing partitioning of the book, and it makes things easier for you. One chunk of data or logical slice of data, you can take it as one chapter, okay? So instead of one complete huge book, you see it as like chapter 1, chapter 2, chapter 3, and much more. So each of the chapter in real life example is representing partition. So this was a realistic kind of example, but when we talk about database, so instead of taking as like complete all huge data, you divide it in multiple partitions like partition A, partition B, partition C. And each of the partition will contain a subset of rows based on some rule. Now these rules can be like the partition can be decided by some key range or hash, or like we discussed earlier, consistent hashing. So basically node is a machine, whereas partition is a chunk of data. Now one thing comes in mind is like, where does partition reside? So partition lives on machines only. So partition lives on nodes, okay? So like this, you can see node A has partition P1, node B has partition P2, node C has partition P3. But the important thing is that this mapping is managed by the database and not your application. So this logic of partitioning, the horizontal scaling on NoSQL, it is handled at the DB layer. It is not handled at the application layer. So if you remember, we discussed in SQL, this logic of horizontal scaling was handled at the app level and not at the DB level. But in NoSQL, this complete logic of horizontal scaling, the nodes and the partitioning, this is handled at the DB level. Now one question may come into your mind, are partitions always on different machines? Because we said that partition lives on machines, so is it that the partitions always are on the different machines? Multiple partitions per node, which is quite common. The answer is not always, okay? There can be multiple different possible setups. First can be one partition per node. Like here we saw A, for node A we have partition P1, node B partition P2, node C partition P3. But there can be another scenario where we have multiple partitions per node, and this is quite common. So for example, if you see here on node A we have partition P1, P2, P3. So multiple partitions can be on the same node as well. So a node can have multiple partitions, and the next setup can be same partition replicated on multiple nodes. And this is a case of replicas. So here you can see an example where multiple nodes are present in a partition, but this can happen only in the case of replicas. For example, you see partition 1, the primary copy is present in node A and the replica copy is present in node B. So only in case of replicas, same partition can be replicated on multiple nodes. So all of these scenarios are possible. So we won't always say like partition will be always on a different machine or node. Now I know because we have mentioned the node is a different machine. So one question that may come into your mind is like, why NoSQL partitioning is different from the SQL sharding? Because in sharding also we have different shards or machines on which this data is present. So how this NoSQL partitioning is different from the SQL sharding. So say if we talk about the SQL case and we have like 1 million users, correct? So this can be the distributions, user from 1 to 250k, those would be present in shard 1, and then 250k to 500 shard 2, 500k to 750k on shard 3, and 750k to 1 million on shard 4. Now each of the shard is representing a different machine, correct? So this data would be present on different machines. But the main point is this logic, like how you decide which user is going to which shard. This is done manually on the application layer. So it would be something like this. If user ID is smaller than 250k, then we will write the logic like shard 1. So we have selected shard 1. Similarly, we would do the other cases like else if it is between 250 to 500k, shard 2, and like that. And similarly, we would put all the cases and select the shard according to that, and that is handled on the application layer, the code, that code we write. So the basic point is the database is not aware of this logic that we have mentioned. It's the app which decides like where the user data should go to. So each of the shard represents a complete database on a different machine, and that logic which shard is selected is handled at the application layer. Now what are the problems associated with this SQL sharding? As we discussed, application knows the sharding logic and this is not handled by the database. So it is very hard to rebalance, and even if you add a database, it would be painful because this logic is present on the application layer, and it might be something like a hard-coded thing, or you are handling it with some external side, but you need to keep an eye on this logic, correct, whenever you basically add or delete the shard. And another thing that we discussed earlier, join across shards is very difficult, complex, because it becomes the distributed joins and it has its own set of issues. But when we talk about NoSQL, things are different. So you can think of something like shard is a separate database on the separate machine, whereas node is representing the machine running that database. Okay, now this was about the SQL sharding, but when we discuss about NoSQL partitioning, it is the database which will decide all the things. Like for example, whatever key comes, we will apply consistent hashing on it, and based on that you will get the partition, and from the partition you'll get the node as well. So this logic is handled at the DB layer. Okay, so the database does all of this, and it is not handled at your app layer, because everything was handled at the application layer for sharding in SQL, but this part is handled in the database layer for NoSQL. So it's a DB which figures out which is the partition, which is the node, and it routes the request automatically to it. So basically you can say it like it's your database which is splitting the data, which is deciding which partition and node it is. So basically here is the thing, the chart which will make things easier for you. So when we talk about table in SQL, that is a logical structure and that is managed by database, right? When we talk about shard in SQL, it is like full database on a machine, on a different machine. When we talk about different shards, those are like full complete database on different machines, correct? And that is handled by the app layer on SQL. This is an important thing to remember, because this is handled at the application layer. That is why sharding is complex in SQL. When we talk about partition in NoSQL database, it is like a chunk of key space, and this is managed by the database. Similarly, when we talk about node in NoSQL, you can say it as a different machine, and this is also managed by the database. So shard is like machine level split, whereas partition is like data level split. So when I was learning this topic, one thing that confused me a bit was like partition versus the table. So these are completely different things. So as you know, table has the columns, schemas, and you can write queries on it, correct? But when we talk about partition, it is invisible to you. There is no schema meaning when we talk about partition, and it is only used for distribution. You will never query a partition. You used to write queries for the table, right? But you would never query a partition. Another thing is like database will move the partitions around quite freely because it is just like chunk of data. So as we mentioned here, the partition is invisible. Basically, node is the database instance running on the machine, whereas partition is just logical. Node is physical, partition is just logical. Alright, because we have talked about nodes and partition, the next question that comes to mind is, why do partitions exist at all in NoSQL? So why do we have concept like partition in NoSQL? So we mentioned the concept of nodes. So why not just split the data directly by node? The reason is because the nodes change, and if we split the data by nodes, then there would be instability. We want data distribution to be stable. So basically nodes are unstable. Nodes can be added, nodes can be removed, and nodes are slow. But data needs stability, right? We can't keep the data in nodes because those are unstable and they keep on changing. So that's why we require the partitions, because partition is like logical split of data, and we use consistent hashing approach through which things are quite stable and rebalancing is quite minimal. So basically from the key we get to know the partition, and from partition we get the node. Now let's see some of the problems that partitions solve. Number one, say we put everything on nodes instead of partition. So without partition you would have something like this. Node A has 50% of data and node B also has 50% of data. Now if we add another node, node C, because we will keep on doing the horizontal scaling, right? So in order to distribute the data evenly, now each of the node will have kind of 33% of data, correct? So earlier you could see there was 50% data present in node A and node B. Now you can clearly see instead of 50% it should have now 33%. So there would be a huge amount of movement of data from node A and node B to node C. So clearly you can see we will have to move 33% of the data from node A plus node B, because that we will shift to node C. That is why we said it's a huge movement. Now with partition, what we will do is like 100 partitions in total, and those will be distributed among the nodes. Like node A has 34 partitions, node B has 33 partitions, and node C has 33 partitions. So when we talk about movement, only few partitions will move, not all data. Next thing, if we talk about the load balancing problem, there can be a point where some data is hot, like user 1 has millions of requests, because user 1 can be, say, a famous personality, right? Like for example, you have the database for all the users, and then in between you also have the users like who are famous, like Ronaldo or Messi, correct? So there can be a problem like some data is hot. So partitioning lets database split hot ranges and move partitions independently. If we talk about without partitions, the whole node will be overloaded. After this, the problem 3 which partition solve is the failure handling. Say for example, node B dies. You had like multiple nodes like node A, node B, node C, and many more. Say now node B dies, which can happen, correct? Because due to any specific reason, a particular machine or the instance of the database can die, right? So if that happens, whatever partitions were present in node B, those will be lost. Like P4 and P5 say were the partitions which were present at node B, those will be lost. Okay, what database can do is like promote the replica partitions, because as we discussed earlier, there will be replicas of the partitions, correct? So whatever partitions are lost, the replicas will be promoted by the database, and it will reassign the ownerships, right? So in this way, the partition is handling the case of failure, correct? But if we talk about without partitions, what would have happened is like the whole machine would be lost. So that would be a really big issue. So this way, like having the partition solves multiple problems, and that's why we have the concept of partition in NoSQL database. So basically, if we say why NoSQL introduced partitions, because partitions allow automatic rebalancing. As we discussed the consistent hashing approach, through that the load will be distributed in evenly manner, and in case the node is added or removed, that is also handled very well using the partition. Similarly, it is really good when we talk about scaling, and it provides the option of DB controlled routing. So using the partitions, everything can be handled by the database and no application level changes are required. I know maybe still it's a bit confusing for you, so let me explain it to you with a very simple real life example. So without partition, we can think of it as like node is a suitcase, right? So you have this suitcase, trolley bag, correct? And your data is the clothes which are present in it. So multiple clothes are present in it, correct? So you put all the clothes in the suitcase here like this. Now your flight allowed you to take one more suitcase, so you added one more suitcase, correct? So this is the second suitcase. So what you need to do is like move out the clothes manually from here and then put it in this. So 50% clothes you will keep it here and rest 50% of the clothes you will put it here. So let me remove some of the clothes from this suitcase, right? So you are doing this manually, put some of the clothes from here to this one, right? So this is the case when we talk about without partition in technical terms. Now when we talk about the case with partitions, it will be like clothes are packed in small bags, okay? So instead of directly keeping the clothes in the suitcase, what you want to do is like you would want to keep those first in the small bags, and then the bags will be distributed in the suitcase. So instead of keeping all the clothes like this, now I have multiple bags out there, okay? And inside the bag I have these clothes. Similarly, one more bag here, and inside this I have kept the clothes. One more bag here and kept the clothes here. So you can see I have like 4 bags in this suitcase 1. And now if I add the suitcase, so instead of manually putting the clothes there, what I'll do is like I'll just simply move the bags. So these 2 bags I'll simply pick and put in this other suitcase. So I'll simply keep these 2 bags inside this suitcase and these 2 in this suitcase. So it makes things quite easier for you, correct? So the partition here is acting as your small bag. Node was like suitcase as like earlier example. So the DB instance running on different machine is acting as the node, just like the suitcase here. But the partition is the small bag inside which you are keeping the clothes, or in technical terms, partition will have the data. So instead of manually moving the data from one machine to another machine, you will just take the partition and move some of the partitions, okay? So it makes things quite easier for you, and that is why we have the concept of partition in NoSQL database. So basically partitions exist so data can be moved, balanced and replicated independently of the nodes. As you can see in this example as well, instead of manually moving the clothes or the data, what we are doing is like we have the partitions. So we simply move this partition and it makes things easier for you. Data can be moved, balanced and replicated independently of the nodes. Alright, so we have mentioned it multiple times that in SQL database, the sharding logic or the horizontal partitioning or the horizontal scaling, that was happening at the database level, whereas in NoSQL, this logic of like horizontal scaling or partitioning, this is basically handled by the database layer. So the basic question that would come into your mind is like, if NoSQL can do DB level logic to do the horizontal scaling, why can't SQL database just do the same? So a simple answer to this question is SQL database cannot do that without breaking their core promises. Now, what were the core promises that were given by SQL? Those were strong ACID transactions. We discussed about the ACID properties earlier in this video, and we mentioned that it's a main kind of feature that SQL provides, correct? The second promise is joins across table. So SQL or RDBMS is like relational database, which means multiple tables are related to each other via the keys, correct? And if there are multiple tables, then you would require to join the data, and SQL is good in joins, correct? And the third thing is the constraints, like the foreign key, unique constraint and much more, correct? So these were the promises that were provided by SQL database. Now basically these promises assume that data is local, locks are local, and order is known. Now when we talk about NoSQL DB level consistent hashing, that assumes data can live anywhere, okay, and nodes can disappear, network can fail. So this directly conflicts with the SQL promises. So let's try to understand this with an example. Okay, so let's say these two are the tables, users table and the orders table. First we'll take an example of SQL. Okay, so what we'll do is like we'll do a transaction in SQL. So what are the operations in that? We'll do the begin, we'll do the insert operation in the orders table and put some values in it. Then we will do the update operations on the users table and we will update the balance. Okay, and then we will finally commit. So this is one transaction, so all of the operations will be part of one transaction only. Now because SQL guarantees the ACID properties, so SQL will guarantee all the operations in this transaction, correct? Like these two operations, insert and update, either both succeed or both fail. It won't happen that one will succeed and one will fail. In case that happens, it will roll back the other operation as well to the initial state, correct? The atomicity feature in ACID, correct? Another thing the SQL guarantees is the balance will never be wrong or there is no partial state. So basically, as you remember, we follow the ACID properties in SQL database. So this was a case of normal SQL. Now let's imagine SQL is following the DB level consistent hashing that we follow in NoSQL database, correct? So something like this can happen. The user ID 101 can be on node A and the order ID 1 can be on node B. So when we talk about this situation for these operations, so what will happen is like the first operation is on the orders table, correct, and on the ID 1. So order ID was on node B. So what node B will do is like insert the order, correct? So the next thing was update users table with ID 101. So 101 user ID was on node A. So node A will update the user balance. But let's say before this step, okay, the step 2 where we had to do it on node A, the network fails between A and B. Then in that case, the order has been created but the balance was not updated. So clearly you can see one of the operation is successful, one can be failed, correct? So in that way the ACID will be broken because the A in ACID stands for atomicity, like all the operations which are present in the transaction, either everything should be successful or everything fails, roll back to the initial state, correct? But that is not happening here because we have different DB instances on different machines, correct? Each of the node represents a DB instance on a machine. So we have different machines, and in case we are having like multiple operations on different nodes in a transaction, but due to some issue there was a failure between the two machines, they cannot communicate to each other, so one of the operation passed and one of the operation failed. So if we were following this in SQL and if SQL tries to fix this issue, it would need a distributed transaction because we have like distributed system now, right? Like node A and node B, different DB instances of different machines basically. So you would require the distributed transaction, you would require the global locks because we have different nodes here, and what this will cause is like high latency, low availability and huge complexity. Now why SQL refused to do this automatically? Because now we are talking about like the distributed nodes, like you have node A and node B, some data can be present on this one, some data can be present on this one. So just imagine like if this is happening automatically, a very simple query like this, select star from users, join orders, we are applying the join here. But the problem here is like we have different machines here. So you would have to fetch data from multiple nodes and you have to move data over network because these are different machines. Now it's not like data is present in single machine, you have different nodes, which mean DB instance on different machines. So the joining of data would be like the interaction happening over the network, right? And it would also require to lock the rows across the machines. It is kind of the similar problem that we were discussing in sharding as well, right? Because in sharding we said like it would be on the different machine, it became like the distributed joins. So the similar problem appeared here as well when we talk about following the DB level consistent hashing, because here also we have like the nodes present, correct? So overall the SQL performance would collapse. Like sharding is a complex thing in SQL, similarly this would become a complex thing. So that is why in SQL the philosophy is that it will stay single node per transaction to keep things simple. If you want distribution, you decide it on the application layer or you apply the logic on app level. That is why we don't do it on the database level, because if we start doing it automatically on DB level, all such kind of issues will appear. And overall, because the ACID properties are guaranteed in SQL, things will become very complex and the performance of SQL will collapse. So that is why we do handling on the app level in SQL, which is like controlled distribution. So what we will do at app level is like, so basically this logic of like sharding will be done at the application layer. So application knows the user ID is the shard key and users plus orders are co-located because we do the control distribution. So app ensures user 101 that we were talking about and his orders like the order ID 1, those will be on the same database. And now the transaction is safe again because you have to apply the ACID on the same kind of DB, and even the joins will happen on the same database, same machine. So you don't have to do it like on the separate machines, because you are handling that at the app level. So everything is controlled here. So basically the app based sharding, it limits where SQL is distributed, whereas when we talk about DB based consistent hashing, it distributes everything blindly. Okay, so that is why we use the app level based sharding in SQL database. But now you will say how the consistent based hashing is working for NoSQL. So now let's see the same example in NoSQL database, what happens and how it handles it. The main funda is NoSQL changes the rules. The rules for SQL were different. It has to follow the ACID properties and all the priorities it has, whereas NoSQL has its own set of rules. It has its own set of priorities. So this is one of the example of how you will keep the data in NoSQL. So we have taken the example of Cassandra database in NoSQL. Later in this video when we discuss like the types of NoSQL databases, but here you can see we have like orders by user, which contains the order ID and the order list. So everything for user 101 would be in the same partition and same node group. So basically NoSQL does not promise multi-table transactions, joins or foreign keys. The joins and the foreign keys are for RDBMS because it means like a relational database. The multiple tables can relate to each other using the keys, and SQL is famous for joins, but NoSQL does not promise anything like that. So basically what it can safely do is like based on the user ID hash, it will find out the partition, and from the partition it will get the node. So no global coordination is required here. So long story short, if I have to tell you in a very simple way, why do we have different handling in SQL and NoSQL? Why SQL handles this logic of sharding at app level whereas NoSQL handles it on DB level? The reason is both of these databases promise different kind of features. Like SQL promises you ACID transactions. Like SQL provides you feature of ACID properties, correct? Strong consistency, relation between different tables using the keys, and it is good in joins, correct? Whereas NoSQL has its own sets of features and priorities. NoSQL doesn't guarantee you following the ACID properties across the nodes. Okay, so if I show you in that table form, if SQL adds DB level hashing instead of handling that at app level, then if it has to keep the ACID, it will become very slow and unavailable. The example that we just saw before this, correct? And if it drops ACID, it becomes NoSQL because NoSQL doesn't guarantee ACID across nodes, whereas SQL guarantees the ACID properties. So if you keep ACID using this approach of NoSQL, then it becomes very slow and unavailable. If it drops it, then it is no longer SQL, correct? Then it is a NoSQL. If it keeps the join, it breaks the scalability because you have to now apply the join across multiple nodes. Again, it becomes like a distributed join, right? Which is very difficult. Whereas if it drops the joins, it breaks the SQL promise, correct? So you can't keep everything. So both of these, SQL and NoSQL, have their different set of properties and promises they provide, and based on that they handle it in their own way. Now another thing is, in the modern scenario there have been a few database which are combination of both of the properties of SQL and NoSQL. So they are providing both of these, which we will discuss later in this video at the end. But they come with their own set of challenges, like they are really expensive in some of the things. Okay, so basic point is SQL, NoSQL provide different kind of promises. Okay, and based on that they handle it in a separate way. So SQL handles the horizontal scaling or the sharding using the app level logic, DB level consistent hashing approach, you can say. So next, let's discuss about what are the types of NoSQL databases. Alright, so these are the four major types of NoSQL database. First one is key value database. Some of the examples are Redis, which is very famous. Another example is DynamoDB. Okay, how key value database stores data in terms of key value pair. Just like you know the hash map or dictionary, right? You have the key and corresponding to that you keep the value, right? In similar way, key value databases also keep the value in key value pairs. Okay. The next type is the document database. Some of the examples are MongoDB, which is very famous, CouchDB, Firestore. And how data is stored in this one? Data is stored in JSON-like documents. Don't worry, we'll discuss about each of these in detail, but for now let's take a brief summary. Okay. The third type is wide column databases. Some of the examples are Cassandra, again very famous. Another example is HBase. Okay. How data is stored in wide column database? In this you have like dynamic columns. So rows will have the dynamic columns, and these are optimized for write heavy workloads. So you would have dynamic number of a lot of columns present in wide column databases. Okay. The fourth category is graph databases. Some of the examples are Neo4j and Genus Graph. Now how data is stored in graph based databases? Using the nodes and edges, because as the name suggests, graph is a format. So we store it in the graph format using the nodes and edges. Okay, so these are the four types or categories of NoSQL databases. So what we will do now is like walk through each of these in detail so that you get more clarity when which one should be used. Okay, so let's start with the key value database. And of course the first question that comes to your mind would be, what is a key value database? The basic funda is the key value database will store the data in terms of key and value. So this is the key, and corresponding to this is the value. Okay, so you can think of it as a dictionary or a map or hash map, but the major part is data lives on disk. When you talk about like hash map or dictionary, then we know it is not persistent storage, right? But here when we talk about key value database, the data lives on disk and it is distributed across machines. So it is not like if your machine goes down, all the data is gone, correct? Because when we talk about hash map or dictionary, it is like when your process is killed, that data is also gone, correct? But when we talk about key value database, it is like distributed across machines. It is also like fault tolerant and very fast. So this is an example how data is stored in key value database. Okay, so this is the key. You can see user 101, this is the key, and corresponding to this we have this value where we have stored the name of the user and age of the user. Okay, as we discussed earlier, one of the example of key value database is Redis, which is very famous. So some of the properties of key value database is that it is extremely fast. It has very simple structure, as you can see here. How it is fast? Like basically you can directly get the data based on the key. So you will basically search via key and you will simply get the value out of it. Okay, and it is easy to scale as well. So these are the good things about it. What are the challenges? It is not good for joins and it is not good for complex queries. So basically you cannot ask it like give me all users older than 25, because everything is based on key here. So it is not good for all such queries. And you cannot ask like join users with orders, because It's not good for joins. Okay, you can ask it like, give me the value for this key, as we are storing the data based on the key. So when you ask for a specific key, it will return you the data or value very quickly. Okay, so if we talk about the use cases of key value database, it is used for caching. Yeah, Redis, as we know, it is very good for caching, very quick. It is also used for like session storage, rate limiting, and OTPs. You might have already used Redis for all such things like storing OTPs or for caching purposes, right? So these are the use cases of key value database. Now, as we are talking about key value database, one question that may come into your mind is like, why key value databases exist? Basically, key value database optimize in one thing extremely well, which is fast access by key at massive scale. So as it stores the data like in key value format, so even when we talk about scale, if you give the key, it will give you the data corresponding to that key very quickly. Okay, so that is what it is amazing in. So these are the problem which key value database solve. First one being millions of reads or writes per second. Then low latency, simple data model, and easy horizontal scaling. Now because it is a NoSQL database, of course horizontal scaling is one of the features of that. But when we talk about like quick access based on key, I mean key value database are best in that part. Okay, and also you could clearly see it has like very simple data model, like you put the key and corresponding to it you can put the data. Right now, some of the core operations that we have in key value database are basically you will provide the key here, and based on that you'll get the value. Okay, so it will be used to fetch the value. It is very similar to what you might have used in like hash map or dictionary, correct? So any language that you have used like Python or Java, in Java you have the hash map, correct? So you have this get method out there through which you get the value of the key. Similar to that, most of the key value database provide this operation of get, where you provide the key and corresponding to that you'll get the value. Next operation is put, again very similar to the hash map thing in Java. You might have already worked on it. So basically you provide the key and the value. It is kind of the insert operation, you can say. So it will store the value corresponding to this key, it will store this value. Okay, next operation is delete operation. So you will provide the key and it will remove that entry. Okay, another operation is exists. Basically through this operation you will simply check so whether this record exists or not. Now some of the key value database support TTL, which is time to live. So it is kind of expiry that you can set. Some also support atomic counters, like Redis provides like the INCR atomic operation, correct? And some supports conditional writes as well, which we have used in this system design video as well. Go check that out, you'll get the clarity how we are using these things. This is a good concept that you can use while designing your system design problems, correct? And some key value database also support conditional writes. All right, so now we know like how key value database stores the data. Next question that comes in the mind is how data is stored internally in key value NoSQL database. So basically the step one would be the key hashing. Okay, so based on the key that you provide, it will find out the partition using the hashing. Step 2 would be from the partition you'll get the node, and step 3 would be the value is stored in the node, which can be in memory, on disk, or on both. So it is something like this. First you have the key and then you do the hashing on it, from which you'll get the partition. From partition you'll get the node, and when you get the node you store the value in the node. Quite similar to what we discussed earlier in this video about NoSQL, right? We had like data, we had like node, we have the partition. So that example also that I told you earlier, the suitcase having the boxes and inside the boxes you have the clothes, correct? All right, next let's discuss about the horizontal scaling, or how key vault database scales so well. So the first reason is no joins and no complex queries. So as we discussed earlier, it stores the value based on the key. So you will simply give it the key and it will return you the value. So here we are not doing any filtering, no scanning, no joins. So the database will only look into the keys that you have provided and it will not look on other keys. So basically each of the requests will touch only one partition and only one node. So we are not doing any range based queries or checking other keys, you simply provide the key and it will check that particular value. So it will hit a particular partition and node only. Now the second reason is it is perfect for consistent hashing. As we discussed earlier, in NoSQL we use a consistent hashing, and here in key value database it fits perfectly well. So based on the key you get the partition and hence you get the node as well. So as we are doing the consistent hashing, so when you add the nodes or remove the nodes, you would require minimal data movement and there is no schema impact. Very similar to the example of suitcase, the boxes and the clothes that we discussed earlier. Okay, that's a very simple example through which you'll get the complete clarity of the whole picture. I know we have not discussed in detail about consistent hashing, so if you want me to discuss about consistent hashing, the complete approach, how things are stored, put that in comment section. I'll create a separate video for that. Alright, so this was about the horizontal scaling. Next, also discuss about the replication and fault tolerance in key value database. So most of the key value database replicate data. So for example, if we put the replication factor as 3, it means it is kind of maintaining 3 copies of the data. So for any key, say K, we have 3 replicas in node A, node B and node C. So just in case one node dies, read and write operations will still succeed. They can be rerouted to a different node because we have the replicas. Alright, next let's discuss about data modeling in key value database, or what are the rules that you should follow in key value database. Alright, so this is the rule 1, which is you should design the keys carefully. As you know, in key value database, everything is stored in terms of key and corresponding to that the value. So it is very important that you design the keys very carefully. Like we'll take the example. So this is a good key design. You have like user 101, session abc123 and cart 101. So basically you are getting the category and corresponding to it the ID as well. So this is acting as a good key. The bad key design would be just user. Now because user can have many user IDs like user ID 101, 102, 201, whatever. So this is not a good key design because there is no uniqueness, whereas this is a good key design. You're getting the category and also the ID corresponding to it as well. So the combination of this is acting as a key. Okay, and then corresponding to this you will store the value. So it means for user with ID 101 you have this value stored, right? So it is a good key design in that way. So apart from this, you can also keep composite keys in key value database like this. You have the category, you have the ID, and you are also storing something else with it. Like here we are storing the timestamp. So it is a composite key. So you can clearly see in the key itself you can keep multiple things through which you can uniquely identify. So here you can keep data for particular order with particular ID and at a specific timestamp, because it can also happen like for a particular user you might have multiple records and you want to keep it with particular data like the timestamp, right? Which can also help something like in rate limiting, like you have specified like in 1 minute you cannot make like more than 100 requests, something like that, correct? So you can keep your key according to it so that you can easily calculate, right? Now next let's compare key vault database with the SQL database, because till now we have studied about SQL database and we know a lot of things about SQL database. So let's compare both of these so that you get more clarity about it. Okay, so first feature is the queries. In key value database you basically query only based on keys, okay, whereas SQL is rich in queries. You saw earlier in this video we wrote multiple queries. Even for joins we wrote different queries, right? So SQL is rich in queries, whereas when we talk about key value database you can query only based on keys. Next, talking about the schema. In SQL we know we have the fixed schema, correct? So SQL is famous for fixed schema and then relation between different tables using the keys, joins, asset properties, whereas in key value database there is no schema. Corresponding to a key you can keep any value. So in value you can keep anything. So there is no fixed schema. Okay, talking about the scaling for key value database, as we discussed, the scaling part is excellent also because it's a category of NoSQL database. By default it is good in horizontal scaling, correct? So this is happening automatic. This logic is also handled at the DB layer, right? Whereas when we talk about SQL we know like the horizontal scaling or the sharding is quite hard, that we already discussed earlier in this video. Talking about the transactions, of course SQL provides like strong ACID properties. So the ACID properties in transaction for SQL, it is quite strong, whereas for key value database it is limited. And when we talk about the use case, of course SQL is used for providing the ACID properties support. It has strong consistency, so it is used for financial transactions, the banking apps, whereas the key value database, it is used for hot path. Okay, so the key value database is excellent when we talk about like the massive reads happening at the scale, because you will simply query based on the key. Okay, so this was about the key value database. If I have to define the key value database in summary, it would be the key value database store data as key value pairs. Okay, and they optimize for fast access by key. You will query only based on key here. Okay, they scale horizontally using the consistent hashing, and they have limited query capabilities because you can only query based on key. You cannot do range queries or other things. Okay, now another thing is like key value database often favor availability over strong consistency. We talked earlier about the cap theorem, right? We can only provide two of the three things in the distributed system, where we know P is a required thing. So either we can do CP or AP. When we talk about key value database, they generally provide AP, that is they prefer availability over the strong consistency. Next thing is the common use cases of key value database is caching, session storage, rate limiting, and for other metadata. And two very famous examples of key value database is Redis and DynamoDB. So let me put it here, Redis and the DynamoDB. These are very famous key value databases. Okay, so this was about the key value database. Next, we are going to talk about the document database. The very first question that comes to the mind is, what is a document database? So a document database is a type of NoSQL database which stores data as documents, usually in the JSON format. This is an example how data is stored in the document database. You can see this is in the JSON format. So here you can see we have information related to users. So we have user ID, username, email, and the addresses of the users as well. So all the information that is required related to user will be stored together in the JSON format. Now the important thing is each document is self-contained, schema flexible, and stored as one unit. Okay, so all the information which is required, which is related to that user, will be stored as one unit in the JSON format, and the schema is also flexible. Okay, so it's not like schema is fixed, it is flexible. Now let's see some of the properties of document database. They have flexible schema, as we mentioned it here as well, correct? They can have nested data, okay, because this is JSON format. Inside this you can keep like nested data. Okay, and these are good for horizontal scaling, like the basic property of NoSQL database. And we will use limited joins here because, as we discussed earlier, NoSQL databases are built in such way by design that we don't require joins. So NoSQL databases are not good for joins, right? So what are the use cases for document database? You can use it for user profiles. Like here you can see we have saved the user related information. All the information related to that user will be present in the document as a single unit, and it would have this flexible schema as well. Another use case can be product catalog, CMS systems, event metadata. So if in your system schema evolves frequently, then we can go for document database because we have flexible schema here. And as we discussed earlier, in NoSQL databases, we try to keep all the related data together. So here also you can see we keep all the data as a single unit. So that's why as per the design, it is built like this, that joins are not required. Now let's see some of the core characteristics of document database. Okay, so in document DB, the data unit is document, and the format of document can be JSON or BSON. Talking about the schema is flexible in document database. When we talk about joins, document DB is weak in joins, or you can say it provides limited kind of support for joins because it's a category of NoSQL database. And then when we further talk about scaling, it is good in horizontal scaling as we discussed earlier, by default NoSQL databases are good in horizontal scaling. That logic is handled at the DB layer and that is automatic. And when we talk about the queries, so document database is rich in queries, not like key value database where you could only query based on the key. Here you can write the queries, but of course it is not at the level of SQL, because in SQL database you can write a very rich level of queries, right? So you cannot compare it with the SQL one, but yeah, as compared to key value database, document DB is much better in terms of queries. You can write a lot more queries here. All right, next let's discuss how data is stored internally in document database. So the step one is collection. So in document DB you have something called as collection. Like when we are talking about like users related information, like we stored user related data here, correct? So this will be one collection. Okay, so the next thing is we store a single unit as document, right? So each of the document has a unique ID. Okay, and then when we talk about the storage, it is stored on disk. It is indexed by ID, like this ID that we have for a document, correct? And then it is often compressed. Now I know that most of your understanding has been related to the SQL database, like we have tables, rows and columns. So let's try to visualize this in SQL format. So you can think of it something like this. When we talk about collection, it is something like a table that we have in SQL database, correct? So in SQL database, we store everything in the table format, correct? In similar way, in document database, we have collection. So like we have the users table in SQL, we will have the users collection in document database. Next, as we discussed, the data unit is document, correct? So you can visualize it as in SQL, we are talking about the row. Like in each of the row, we had the data, correct? So in similar way, in document database, we have the single unit as document. And in SQL, we have the columns, right? Like for example, this can be your user ID, name, address, right? In similar terms, we have fields in document database. But the important part is like in SQL database, structure or the schema was fixed. Whereas when we talk about document database, the schema is flexible. So the fields in document database will be flexible, right? So in document database, we have collection, document, fields. And then when we talk about storage, it is stored on disk, indexed by ID, and they are often compressed. All right. Next, let's discuss about the query compatibilities in document database as compared to key value database. So we saw earlier that in key value database, you can query only on the basis of key. So you cannot make any other queries. But when we talk about document database, it is much better in terms of query capabilities as compared to key value database. Like for example, we took the case here of the users, right? So this was an example of document database where we had the user ID, name, email, addresses, everything stored in the JSON format as a single unit document, right? So what we can do is like we can query inside this document. Like if we want to query for this address related to Delhi in this document, then we can write a query in document database something like this. You can write db dot users is our collection name, correct? And then we can do dot find. Inside that you can provide addresses dot city Delhi, because we have saved in the JSON document addresses, and inside addresses we had the city, correct? And this is the name of the city that we want to find. So I've pasted that example here so that you can relate it easily. Okay, so this was our users collection, and you can see this was the document in which all the data was stored, and we have done db dot users collection dot find addresses because we want to find inside this field, and then we have put dot city because we want to search for this Delhi city, right? And then we have provided the name for that. So the document database supports filters, sorting, range queries, and aggregations. So you can clearly see that as compared to key value database, the query capability is quite rich in document database. Alright, next let's discuss about data modeling in document DB, which means how do you want to store the data so that it's efficient while reading? The golden rule for this is model data based on the access patterns, which means depending on what is a pattern that you access the data, you should model it accordingly. Let's try to understand this with the couple of ways of data modeling. So the first way of data modeling is embedding, which is the preferred way. Okay, so you can see this is the embedding way of data modeling in document database, in which you can clearly see all of the complete data. It's stored in the single document as a single unit. Okay, you can clearly see we have the user ID, and when we talk about the orders, we have the details of orders as well, like order ID 1 and the amount is 500, order ID 2 amount is 300, right? So we have details related to order ID as well. So what are the good things? You can get all the details in one read. Okay, the details of orders are also present in the same document, so you won't require any join here, correct? Because all the data which is required for this particular user ID related to orders is present in this one single document. Okay, the second way of data modeling is referencing, and we use it when it is required. So this is not the preferred way. Preferred way is embedding, where we have all the complete information in the single document, but the second way is referencing, and we will see when it is required. Okay, but this is the format in which you store. You can clearly see we have the user ID here, same thing. But when we talk about the orders, we don't keep the complete details here in the single document. We have just kept the order IDs here, 1 and 2, but we have not kept the detail related to that order. Like for example, we maintained the amount as well in the first case of embedding, but we have not kept the amount or whatever detail was present for that order ID here. Why? Because this is used when your data grows too large. Say for example, in this document you had huge amount of data. Okay, so you can't keep everything in a single document, correct? It would be like everything has a limit, so you can't make everything in the single document. So the case where your data grows too large, okay, so instead of embedding we will use referencing there. So we will only keep the important information in it, like the order IDs, and then if required we can find out the details of the order IDs from a separate document. Of course, you clearly see these were the use cases of embedding which we might not get in referencing, correct? But again, we will use it when we have independent life cycle kind of a state. You can imagine, like we would only require the order IDs, but we don't always require the details of those orders. Okay, it can be something like on UI you have a screen where for the user you can simply see the orders. Okay, like order ID this, order ID this, order ID this, and then when you click on a particular order you show details of that order, correct? So for this screen you can say this would be fine as well, right? So as per the requirement you can pick referencing, but of course embedding is the preferred one. So these are the basic two ways how you can model the data in document DB. Okay, so depending on the requirement, like what is the pattern of your access, you need to model your data. Okay, next let's discuss about joins in document database. Of course, we know that in NoSQL joins are weak, correct? Because overall NoSQL are designed in that way that you don't require that much joins. Now when we talk about specific to document database, some of the document database like MongoDB, it supports joins. Okay, so for example in MongoDB you can use lookup. Okay, but it happens at the query time. These are not optimized for scale, and cross shard joins are expensive, right? We already know all this information, and that's why we also know denormalization is preferred in NoSQL database and also in document database. Next, let's discuss about horizontal scaling or sharding in document database. So as we know, document database is type of NoSQL database, and we have already discussed some of the things in NoSQL database. Like NoSQL database are good in horizontal scaling, and that is kind of the automatic feature because it is handled at the DB level. So same for document database, it happens at the DB layer. Okay, so one of the example can be, say user ID is your shard key, and based on the user ID you'll do the consistent hashing, you'll get the partition, and through that you'll get the node. So all of the data for a user stays together, the same things that we discussed earlier. Okay, now for shard key we discussed earlier as well. I'll just repeat, like good shard key is where you have the high cardinality, even distribution, and it is used in the queries, whereas bad shard key will be something with low cardinality and which create hot pods. Next, if we talk about like cap theorem in the document database, as we already know, like when we talk about distributed systems, either we can follow consistency with partition or we can follow availability with partition, correct? When we talk about document database, most of the document database follow consistency with partition tolerance. Like for example, in MongoDB, CP is by default. So consistency is given more preference than availability in document database. So as I mentioned MongoDB here, so MongoDB is the most famous example of document based databases. Okay, MongoDB is quite popular and you might have already used it as well. Okay, so it is a type of document database. Okay, so if we talk about document database in summary, so document database stores semi-structured data as JSON like documents. So the data unit is document and the format is JSON. Now document database provide flexible schema, rich querying and horizontal scalability. Okay, now instead of joins they encourage denormalization and data modeling around access patterns, right? So we will mostly use embedding related data modeling so that all of the data is present in the single document only, so you don't require any joins. Okay, so document database is equivalent to JSON native database optimized for reads. All right, so this was about the document database. Okay, next, let's discuss about wide column database. So the question that comes into mind is, what is a wide column database? So basically in wide column database, we have concepts like row key, column families, columns and values. So corresponding to a row key, you will have like column families and columns, and corresponding to that you will store the values. It looks like a table, but it's not a relational table. Okay, so think of it like each row can have millions of columns, so that's why it's called wide column. So every row can have millions of columns, but the important part here is the schema is not fixed. The columns are created on the fly. So the rows do not need to have the same columns. Different rows can have different columns. Don't worry about it. We'll discuss more about wide column database and you'll get the complete clarity. Okay. So for now, let's see why wide column databases exist. So basically in wide column databases, the data is stored like the rows with dynamic columns, correct? And they were created for massive write throughput. So wide column database is optimized for write heavy workloads. Okay. Apart from that, they are also created for time series data. We'll discuss about it more. Then for event logs and for analytics at scale. Another thing about wide column database is that they are not good for complex queries. So complex queries are hard in wide column database. All right, now because we said in wide column database, we said like we have the row keys and we have the columns. So you might confuse it with SQL. So let's try to understand like how wide column database is different from SQL. Okay. All right. So first what we need to do is kill the SQL mental model when we talk about wide column database. So in SQL table, we used to have like fixed columns, schema was fixed and joins are supported, correct? But when we talk about wide column database, we have dynamic columns. Okay. And it is schema-less. So schema is not fixed and there are no joins. So if you think table, you'll get confused, but you need to remember in wide column, we have dynamic columns and without any schema. But again, you'll say, we talked about row key, column family, columns. So what are they? So for that, let's try to understand the core concepts in wide column database. So the first concept is row key, or we can also say it as the partition key, which means everything for the same row key is stored together. So for example, user ID 101, this is acting as a row key and corresponding to it will keep all the data for it together. So this was the first concept. The second is the column family. Okay, basically it's a logical group of columns. That is why it's called column family. So for example, user profile, user orders. Each column family is stored separately on the disk. So a logical group of columns is column family. Then the third concept is columns. And as we said, in wide column database, columns will be dynamic. So the important part of columns are that they can be added anytime. So these are the example like order underscore 2025 underscore 01. So basically we are using the timestamp, you can say, and corresponding to that we have stored the value, say 500, and for next we have stored 300. And the fourth thing is cell. So each of the cell will contain the value corresponding to the row key, the column, and the timestamp. Okay, based on these we will have the value stored in the cell. Now you can clearly see we have mentioned the timestamp here, and that's why we mentioned that wide column database are created for time series data as well. Okay, so here you can see in the cell we have like row key, column, timestamp, and based on that we are storing the value. Now let's try to understand this with an example. Okay, so here you can see the row key is user ID and we are talking about user with ID 101. Okay, so the column families are order. Okay, so this is the information related to user ID 101. Order 1 value is 500, order 2 value is 300, order 3 value is 900. Now when we talk about another user with user ID 102, so the row key would be user ID 102. Column family again orders, but here you can see we have put order 7 200. So clearly you can see we have different number of columns per row, and that is totally fine in wide column database. Now earlier we mentioned that wide column database have high write throughput. So let's try to understand why writes are extremely fast in wide column database. Because in wide column database, there are no updates in place, there are no joins, no constraints, no transaction. Everything is like write, append and done. So basically you are appending the things. And that's why it's perfect for logs, metrics and events. Next, let's discuss about the query model in wide column database. So the query model in wide column database is quite restricted. Why? Because in order to make a query, you must know the row key and the column family. You cannot do arbitrary filters or joins or full table scans. Okay, so that's why overall in wide column database query model is quite restricted. You must know the row key and the column family, and overall the wide column database is not for complex queries. Okay, because we have discussed about the query model in the wide column database, now let's also talk about the data modeling in wide column database. So the rule here is you have to design the tables for queries and not entities. Okay, based on what kind of queries you get, you have to design the tables according to it. Now this is the bad modeling example because we are following the SQL mindset, right? You would have like users table, orders table, and then you will join it later because we used to do it in SQL. But this is bad modeling when we talk about wide column database. And this is the example of good modeling when we talk in terms of wide column mindset. Like we have made orders by user, orders by date. Yes, there will be data duplication and that is totally fine in this NoSQL based wide column database. Okay, so because we are querying in this fashion, so we have created the tables in that way only, so that overall queries are quite efficient and we can store everything together. Next, if we discuss about the horizontal scaling in wide column database, it is very similar to what we have discussed till now in NoSQL database. So data is partitioned by row key. We discussed about the row key, right? And then based on consistent hashing on the row key, we get the partition and then we get the node, and there is automatic rebalancing. So each row is stored together and replicated. Now apart from this, if we talk about the cap theorem, right? As we know, we can either follow the consistency with partition tolerance or we can follow availability with partition tolerance. So in case of wide column database, we give more preference to availability with partition tolerance. Or you can say it's a tunable consistency. More preference is given to availability. Now few of the very famous examples of wide column database are Cassandra and HBase. Next, let's see when to use wide column database and when not to use. So you can use wide column database for time series data, IoT metrics, click streams, event logging and write heavy systems. And when not to use, for complex queries, as we saw that the queries are quite restricted in wide column database, as you need to know the row key and the column families. Similarly, not to use it for joins, financial transactions, and for small datasets. So if I give the brief summary of wide column database, they store data by row key and the column families, and they allow rows to have millions of dynamic columns. They are optimized for massive write throughput and horizontal scalability, but restrict query patterns and avoid joins. Okay, so these are the few of the things that we learned about wide column database. Okay, so we mentioned here that wide column database are used for time series data. So one question that comes into mind is why wide column database is used for time series storage. Okay, so first let's try to understand what is time series data. So time series data means you have the same entity but values keeps on changing over time. For example, CPU usage every second, user activity events, stock prices, sensor readings. Some of the key properties of time series data is these are append only. These are ordered by time and these are mostly read by time range. Now let's see why other database would struggle at time series when we talk about huge scale. Okay, so example is we need to store CPU usage every second. So if we talk about SQL database, we have to keep like time, CPU, memory. So because this is like time series based data, we will have a lot of events. Say we have to maintain the records for every second. You can imagine that after a year, there will be huge number of rows per server and overall the writes will become quite slow. Now let's see how the wide column database will handle it differently. So the wide column database will group time based data together, and in this we will just perform like append. Okay, so when we talked about SQL, it would have been like one row per event, but when we talk about wide column database, it would have one row per entity and many columns over the time. I know it might be still confusing, so let's take an example. Okay, so say we have to store CPU usage of server ID 101 every minute. Okay, so for wide column database, we can say like Cassandra, we will have the table as CPU metrics. Okay, and the primary key will be server ID and the timestamp. So server ID is the partition key and timestamp is the clustering key. So overall the data would be stored something like this, because we talked about like row key, column family, columns and the values. So I'll show you in that way only. The row key will be the server ID because we were talking about SRV 101. So that will act as our row key. Okay, and when we talk about the column family, it would be metrics. So in that we will use the timestamp. You can clearly see this is the date and this is the time, and corresponding to it we have kept the value, and again the next minute we will store another value, and you can see at 10:02 another value, 10:03 another value. So basically we have one row per server and columns are ordered by time. So corresponding to this row key, which is your server ID, we will keep all the data based on the time, and this is already ordered by time. So that's why it's following the needs which are required for time series data. Now this is how the data will be stored in wide column database. So why wide column database is perfect for time series storage? Because of the following reasons. Number one, the writes are append only. Okay, so we are not performing any update operation here. We are just appending the data in the same row key. Okay, so we are just appending. Okay, you can clearly see there is no update operation here. So whenever there is new timestamp, there is a new column. So clearly you can see these all are the columns. So after every minute we are creating a new column. So next would be this time and then 10:04, and corresponding to that we will have the value. So that would be the new column. Okay, and the most important thing, there are no updates. It is just append only and there are no locks. Now the second reason is data is naturally sorted by time. So our clustering key is the timestamp, correct? Like we saw here, the partition key is server ID, the timestamp is the clustering key, and you can clearly see the data is already sorted, right? So that's why the range queries are fast. Next, the reason number 3 is reads are localized. So we will have query something like this: get CPU usage of server 101. This is our row key from this time to this time. So because we are mentioning the row key here and data corresponding to one row key will be present in one server only, so that's why only one partition is touched, and that's why we are saying reads are localized. So you do not need to pick data from multiple partitions, you'll just pick the data from one partition. Now because we said like only one partition is touched, we also come to point number 4, which is no cross server queries are needed. So each server's data lives together. So you are just picking data from one place. So no cross server queries. Okay. So due to all of these reasons, wide column database is good for time series storage. Next, let's take one more example so that you get more clarity. So in this example, we'll track the user activity events. So our wide column design would be something like this. Our table is user activity. Primary key is the combination of user ID and event time. Now let's see how data is stored. So we will have row key as user ID. So for example, user ID is 101 and corresponding to this, we will have the columns. Okay. At 10:00, we have the login. At 10:05, we have the event of view product. At 10:07, we have an event of add to cart, and at 10:10 we have the event of logout. So based on the new time, we'll create the new columns. Now further, if we talk about the query, it would look something like show user 101, which would be the row key, correct? And then activity today. It will simply hit the single partition because data is stored based on the row key, correct? And all the data corresponding to row key is present in one partition. So basically in wide column database, the partition and clustering makes the time series magic. So the partition key would be the group's entity, like it can be your user ID. The cluster key would basically order by time. Okay. And internally it uses LSM tree, due to which we have fast appends. And another thing that it uses is SS tables, due to which we have sequential disk writes. And these are the reasons that the wide column database become the natural choice for time series data. So we saw the example of user activity events using the wide column database. If we do the same using SQL or any other database like document database, let's see what all problems do we face. Okay, so if we store it in SQL, okay, so we will make a query like select star from activity, which will be the table name, where user ID is equal to 101, correct? Because we have to figure out data based on the user ID, and then we will provide time between. Basically we will provide the range. Now the problems at scale are there will be huge index scans, there will be random disk IO, locking overhead, and if the data is huge, they can be part of different machines, then basically it can create more problems. Okay, now similarly if we compare it with the document database, in document database we will store it something like this. Okay, so we will have the document ID, and inside the document we'll store it in the JSON format, right? So we will have the user ID, and then we will have the activities. Inside the activities we will maintain like time is this, event is this, and then further time is this, event is this. So inside the activities you will have all the data. Okay, now what are the problems? First problem is the document grows forever because you have to keep on adding the data based on time, right? First you have 10:00, then 10:05, 10:10, and it goes on, correct? So your document will also grow forever, and because of that eventually it will hit the size limit. We saw in document database there are two ways to model the data. One would be the embedding way, where you would have everything inside the document itself, but because due to the size constraints, if the data becomes huge, then you cannot follow that way, correct? Then you just keep the IDs out there, but that won't be helpful here because we want to keep the data corresponding to time as well. And another important point here is when you keep on adding the time, it is kind of like updating or rewriting the whole document, because inside the document you have to add this new value, right? So that's why it's not that great. But when we talked about like wide column database, you can have thousands or millions of columns, and those are dynamic, and it is kind of append only operation. Okay, before moving to the next one, which is the graph database, I want to cover one thing. When I was studying all this, so I had a doubt, so I would like to share that with you, and after that let's move to the graph database. Okay, so the question was, what is the difference between wide column database and document database? Okay, because both of these like appeared bit similar to me in the beginning, so I had this doubt. So maybe you also have this kind of doubt, so let me clear this for you. So first of all, like how they store data or overall their model is completely different. In document database, you store the document and generally the format would be JSON, and you will assign ID to that document. So there will be complete document. Whereas when we talk about wide column database, it is special for like the number of columns can be huge. Okay, you can have like thousands or millions of columns, and those will be corresponding to a row key. Okay, and different row keys can have different amount of columns, so the columns are completely dynamic. So both of these are completely different, but let's try to understand more about it. So the first thing, like we discussed, in document database we will store it like in the document. So there will be one document, it will contain all that information. Okay, so say for one user ID we will have one document. Okay, when we talk about wide column database, for one user ID we will have one row key, and inside that we can have thousands or millions of columns. Okay, so how data is present in both is completely different. All right, so the basic unit for document DB is document, whereas for wide column DB it's like the row key. Inside the row key you will have like a lot of columns. Okay, the format, as we said, it stores in document. The format of document will be mostly JSON or BSON, whereas for wide column database, corresponding to the row key, we will have the columns. Okay, when we talk about the schema of document database is flexible. When we talk about wide column database, it is semi flexible, because you saw like for the user ID we have like columns related to the time, right? So the total number of columns can totally vary based on the row key, but still it's kind of semi flexible, we can say. Okay, when we talk about the data shape, in document DB it is nested, as we saw, like it's a JSON inside, so you can have nested things inside the JSON. Okay, when we talk about flat column DB, it is flat but wide, of course, like because we are talking about columns, so there is no nesting, but there can be huge number of columns, so wide in that way. Okay, next, when we talk about columns per row, in this, of course, the wide column database can potentially have like millions of columns. Okay, so these are the kind of differences between document DB versus the wide column DB. All right, now let's try to understand this more with an example. Okay, so we will take an example and see how the data is being stored in like document database versus the wide column database. So in document database we are picking like MongoDB, which is a very famous document type database, and in wide column database we are picking Cassandra, which is also very famous. So corresponding to user ID 101, we are basically storing the orders. Okay, so because in document DB we have the document, in single document will store everything, so you can clearly see this is the JSON. Inside this we have stored the user ID, we have stored the username, and then we have also stored the information of the orders of that particular user with user ID 101. So the first order related information is order ID 1, amount is 500, then order ID 2, amount is 300. What are the characteristics? It's easy to read because you can see everything in one document. It's a JSON document, so quite easy, and in one read you can fetch all of the information, right? So this is like embedded style where all of the information is present in the single document, correct? So in one read you will be able to get all the data. Okay, the same information, how we will store it in wide column database, let's see. So we will have the row key, correct? So the row key is the user ID, which is 101, and then we will have the column family orders. Okay, so clearly you can see the same thing, we are storing it like order 1, and corresponding to that value is 500, and then order 2, and then the value is 300. So these are the different columns that we generate. Here you can see this data is stored in the nested level. Okay, and this was the starting of JSON, and you can see this is the nested level where we have provided all the information of the orders. When we talk here, this information comes in the column. So if you have another order, a new column is created here. Okay, so what are the characteristics of wide column database? very fast writes as we discussed, because this is append only. It can handle huge number of columns, so all the data which keeps on coming, that we will keep on creating new columns corresponding to that, and it is ideal for append only data. That's why it is quite fast in terms of writes. So this was about how data is stored in document database versus in the wide column database. So next, let's also see the difference in the query capabilities between both of these databases. So the first feature is filter by field, right? So you have the field. Can you filter by the field? In document database, of course, you can filter by fields. In the document, you have the fields, right? So in the query, you can mention which field you want to filter by, and based on that, you can filter it by the field. When we talk about wide column database, we cannot filter by field. When we talk about the range queries, in document database, we can do that. And in wide column database also, we can do that by on clustering keys. We saw that example where we use the timestamp as the clustering key, and based on that, we can perform the range queries, right? Next, when we talk about aggregations, aggregations are good in document database, but it is limited in wide column database. Okay. Talking about joins, document database are weak in joins, whereas joins are not at all supported in wide column database. And next, when we talk about the query flexibility, document DBs have high query flexibility in terms of when we talk about NoSQL database. Of course, SQL are much better when we talk about query flexibility, but when we simply talk about NoSQL databases, document database have high query flexibility, but wide column database have very low query flexibility. So clearly you can see the writes are very fast in wide column database because it is doing append only. But when we talk about the query capabilities, document database is better in that. Next, if we talk about what do they use internally, okay, so the document database internally uses B tree, whereas wide column database uses LSM tree. When we talk about update pattern in document database, that is in place or rewrite pattern. When we talk about wide column database, it is append only pattern, and due to append only pattern, the writes are quite fast in wide column database. And when we talk about disk IO in document database, it is random plus sequential, whereas in wide column database, it is mostly sequential. You don't need to remember all of this. I just gave you the brief insights, like what is the difference between those. You should be aware of that very clearly. By now we know wide column database is the write operations, the update pattern is append only, so it is very quick in writes, right? Whereas the query capability in document database is better. Okay, the style in which both of these store data is completely different. That's why these are the different categories of NoSQL databases. Another difference is when we talk about the cap theorem. Now, because we know either we can have CP or AP, by default the document database follows CP, so it gives more preference to consistency over availability. Whereas when we talk about the wide column database, by default it gives preference to availability over consistency. Okay, so it gives you AP, that is availability with partition tolerance by default. And the asset properties, we know those are more specific to SQL because SQL tries to provide you the asset properties overall. But when we talk about basic atomicity operation, so document database will provide you atomicity at the document level, because in a single document you will have all the data, right? So atomicity will be at the document level, whereas when we talk about wide column database, it provides you atomicity at a row key level, because we have the row key and corresponding to it we have the family column and the columns, right? So it will provide you the atomicity at the row key level, which is limited though, but still it is at the row key level. And as we discussed earlier, document database provides you slight support for joins, although it is weak, but still you can have multi-document related transactions. But when we talk about wide column database, there is no support for join. So this was in complete detail. Now, the very basic question that comes to mind, if we have to talk in summary, when to choose document database and when to choose wide column database. So here is the answer. Choose document database if your data is object-like, because it will store the data in a document with JSON format, right? And choose if you need flexible queries, because we saw The document database is provides you much better read query support. Okay, and choose it if your reads are complex, whereas choose the wide column database if you have massive writes, because we have already seen the wide column database is really good when we talk about the write operations, because it is append only and because of the data structures and everything that it uses. Okay, and also choose it if your data grows continuously. In document database, it can create an issue if your data keeps on growing, because your document has kind of size limit. After that, you cannot follow the embedded pattern, correct? And if you don't follow it, you don't have all the data in one place, right? If your data grows continuously, then it's better to use the wide column database, because it has the support for like thousand to millions of columns, and columns are dynamic. As your data grows, you can keep on growing your columns, right? So that is supported in wide column database. And again, use it if your query patterns are fixed, because the read query support is weak in wide column database. Okay, so based on your pattern or the requirements, you can choose between document db or the wide column db, right? So I hope that clears the doubt. Until now, we have covered in NoSQL database the key value database, document database, and wide column database. Next, let's discuss about graph database in NoSQL. Okay, the first question that comes to mind when we talk about graph database is, what is graph database? So a graph database stores data as nodes, edges, and properties. You might have read about graph data structures when you read about data structures and algorithms, right? So we have nodes and edges in graphs. Similarly, in graph database, we have nodes, edges, and properties. So here nodes represents the entities. So if we want to relate it like the SQL database where we have tables, so node will be relating to the entities. Okay, the edges relate to the relationships, like this is the node and this is the edge. Okay, so these nodes act as entities and the edge is acting as the relationship between the entities, and then the properties are the attributes. So one example of graph database is, like if we talk about social network, like we talk about Facebook, Instagram, so in that you have like two people friends of each other, right? So Alice and Bob are friends. So this relationship is stored directly using the graph database. Now, because in social networking apps, you have mutual friends and then friends of friends, right? Like in LinkedIn also. So instead of computing all that information through joins, you can get that relationship directly using the graph database. So graph database is good for storing things like where you have relationships which are deep. Okay, so example is social networking apps. Now you may think like, because there is relationship out here, why not use the SQL or relational database here? So let's discuss about that. Why graph database exists? So basically the relational database struggle in the following cases: when the relationships are deep. For example, we talked about the social networking apps, right? So you can have friends of friends of friends. In that case, you have deep relationships and the queries would require a lot of join operations, because you have to take data from multiple places. And another thing is, when the relationship patterns can change, then the relational DBs can struggle in that. So in these areas, instead of relational DB, you would like to use the graph database. Okay, because graph database is dealing based on the relationship only. Now, because we mentioned in graph database, we have nodes, edges, properties. So let's try to understand each of these in detail in the core components of graph database. So the first one is nodes, and nodes represents the things, or you can also say it is similar to entities. Example can be user, product, city. Now the good part of graph database is both the nodes and the edges can have the values or the properties. Okay, so let's take an example of node properties first. So you can see this is the node user, and inside this we have the properties like ID is 101 and name is Rahul. So for node user, we have defined the properties like the ID of this user is this and the name of the user is Rahul. So after nodes, the second one is edges, which define the relationships. Okay, so edges represents the connections, like this is one node, this is another node, this is the edge, and this defines the relationship or the connection. So example of edge is like this is one node, this is another node, and the edge is this relationship which is friends. Similarly, you have a node user, another node is product, and the relationship is bought, that user bought product. So edges are directional, as you might have also checked that in the graph database. In the similar way, we in the graph DB, we have the edges which are directional, okay, and edges have types and can have properties that we have already discussed, that both nodes and edges in the graph database can have the properties. So this was an example of node having properties, and now let's see an example where edges has the properties. Okay, so this was first node user, this was another node user, so the relationship or the edge was friends. So if we see here, this friends is representing the edge, okay, but it can also have the property. So you can clearly see it has this property since 2020. So this is defining this user and this user are friends since 2020. Okay, all right. So apart from nodes and edges, the third thing is properties, and we have already discussed that both node and the edges can have the properties. Okay, so they can store key value properties like this. You can see ID 101, this is the key, this is the value, name is the key, Rahul is the value, since is the key, 2020 is the value. Okay, so both nodes and edges can store key value properties. All right, next let's see how graph database stores data. Although graph database also talks about the relationships, but it is different from SQL. Okay, in SQL you define the relationship between tables using the foreign key, right? Whereas when we talk about the graph database, relationship is the direct pointer, because you can clearly see the nodes are connected via edges which represent the relationships, and relationships can also have the property. So it's kind of a direct pointer in the graph database. So for example, in graph database, if you have to go from node to neighbor to next neighbor to another neighbor, this traversal is O1 per hop. Okay, so you can directly move to the next one because it's a direct pointer. Let's try to understand this with an example. So we took the example of social media, social network, right? So for example, you have to go like friends of friends in social media. Now this example of friends in social media can be quite painful in SQL. So you have to apply multiple joins user 1, then join users 2, join users 3. Right? So a lot of joins in the query. Whereas when we talk about the graph database, it is built for this kind of thing. We can do something like match. This is the first node which has the property ID 101, and then we are telling the edge. Okay, this is like friends, which is defining the relationship, and then basically we are providing like we have to go friends of friends. Like here you have to do the join operation thrice. Here you are using the direct pointers for that. Okay, so this complete query basically will return you this friend. So overall every hop is like O1, right? So the performance in this will depend on the depth, how many levels are you going, and not the data size. So one of the famous example of graph database is Neo4j. Okay, so this is a famous graph database. So apart from this, the graph database are really good in traversals. Okay, so you might have already seen the graph related traversals when you might have worked on like data structures and algorithms. But in similar way, graph database excel at like shortest path in recommendations, fraud detections, and network analysis. So an example can be find shortest path between A and B. So graph database can use BFS or DFS for this, which is very fast. Next, let's talk about the data modeling in the graph database. So the rule for data modeling in graph database is we have to model the relationships and not the tables. Let's try to understand this with an example. So if we take example of e-commerce, the nodes can be user, product, category, and the edges can be user node is connected to product node via edge or relationship viewed, that user viewed product. User can also be connected to node product with edge or relationship bought, that is the user purchased the product. Okay, and product is connected to category with edge in, so product is in this category. Okay, so based on the relationship you model the data in graph database. So the relationships are really important part of graph database. Next, let's discuss about the scaling in graph database. Now although in most of the NoSQL database the scaling was not that difficult part, it was kind of automatic and quite easy thing, But when we talk about the graph database in NoSQL, the scaling is bit hard. This is because the graph database are excellent on single node, but they are hard to shard. Okay. Why is that? Because the relationships across partitions is difficult to handle. Because the traversals would happen on the network calls and that would be quite slow. Talking about some of the strategies to handle it, it can be partition by community so that you do not have to check for the relationships across partition. You are then able to handle the things in the same partition only. Another strategy is hybrid systems and read replicas. Now for all of the databases, we also checked about the cap theorem, right? So as we know in cap theorem, we can either provide CP or we can provide AP, right? So when we talk specific to graph database, by default, graph database provides strong consistency. So it gives preference to consistency over availability. So if we talk about graph database in summary, graph database store data as nodes and the relationships, allowing fast traversal of complex relationships without expensive joins. Okay, so it is used when we have deep or complex relationships, and because it connects the nodes using the edges which represent the relationships, so it is based on the relationships and you can go from one node to another as a direct pointer. So graph databases are ideal for problems where relationships are deep and complex. Okay, and the pattern matching matters more than the raw data volume. Okay, so overall for graph database, we can simply say it's like relationships stored as pointers. Alright, so now that we have discussed about the SQL and NoSQL databases, let's see with an example how data is stored in SQL versus all different NoSQL databases. Okay, so we will take an example and we will see how the same data is stored across different databases that we have discussed till now. So let's say this is the data. Okay, so we have user and orders. So for user ID 101, we have these two orders, order 1 with amount 500 and order 2 with amount 300. So first let's see how this data will be stored in SQL database. So this is how the data will be stored. We will have a users table, correct, because in SQL we have tables and then we connect the tables using the foreign key, and in the queries we use the joins, right? So we will have the users table for user. In that we will have the two columns like ID and name. We will store the information 101 and the name as Rahul. Okay, and another table would be the orders table. Inside that we will have ID, user ID and amount. Okay, ID here would be the primary key of this table orders. It can represent the order ID, whereas user ID can act as the foreign key, because using this column we can connect users table with orders table. Okay, and then we have amount column. So we will store data like this. Order ID is 1 and user ID corresponding to it is 101 and amount is 500. Another order is with ID 2. The user ID is again 101. The amount is 300. Okay. So this is how the data will be stored in SQL. So next, if we talk about the query, it would look something like this. Like we will use select star from users u. This is the table users. And then we will use the join here because we need data from both of these tables, right? So this was the left table and this is the right table orders, and then we provide the matching condition using on keyword, and we do it like u.id is equal to o.user id, right? So based on this we have provided the match conditions of join, and then we have also provided where u.id equal to 101. Okay, so it will do the filtering after the join because we want data only of user ID 101. Right now let's see when SQL is good and when is it bad. Alright, so SQL is good when we need the strong ACID transactions because SQL provides strong ACID support, right? We discuss about ACID properties, atomicity, consistency, isolation, durability, right? And then the next thing is SQL is really good for joins. So the joins are powerful. You can clearly see we have used the join operation here. Next, SQL provides you strong consistency. So when data consistency is required, you want guarantee on that, you can use SQL. Okay. So these were the good things for SQL. Now let's talk about the cons of SQL. SQL is hard to scale horizontally. That is, the sharding part is quite difficult, and that is managed by the app level logic. Another thing is the joins become slow at scale. Okay, so if you have many joins, it becomes difficult and it will be quite slow. Third thing is schema changes are painful in SQL. Okay, so this was in SQL database, like how data will be stored, how we will query, good things and bad things. But apart from SQL also, we discussed about NoSQL, and inside NoSQL we checked about the 4 categories, right? So let's discuss how this data will be stored in all of those 4 categories of NoSQL as well. Okay, let's start with the first one, which is the key value database, right? So the famous examples of key value database are Redis, DynamoDB, correct? So let's see how the same data, this one, will be stored in this key value database. Alright, this is how the data can be stored. You can see the key we have maintained as user 101. So basically it is telling about user and this is the ID, and corresponding to that we have stored the information. Like you can clearly see we have stored inside the value name as Rahul, and the orders information also we have stored. We had like 500 and 300, so we have also put that inside the value. Okay, so this is the key. This complete is the value corresponding to this key. Next, this is how you can read from this data. Okay, so this was your data, and if you want to read, you will simply do get and then pass the key, because the key was here user column 101. So we have passed the key here, and corresponding to it, it will return you this value. So like in SQL, we saw what are the good and bad things. Let's see same for the key value database. First, talking about the good things, the key value database is extremely fast. Okay, so basically your query is just using the key, and you pass the key, you get the value. It is very fast. Then because it's a NoSQL database, there is easy horizontal scaling. So horizontal scaling was a con in SQL, but it is totally fine in this key value database. And key value database is perfect for cache and the sessions, because there you can keep the data in key value format and it will be very quick. Okay, so these are the good things of key value database. Now let's see the bad things. So first bad thing is you cannot query inside the value. So you can simply query for the key, like you give the key and you get the value, but inside the value, say for example we have this orders, you cannot query for this. So you cannot query inside the value. Okay, next thing is you cannot do any joins in the key value database. It's not supported. And another point is it is poor for complex data. Here you can see everything is present in this value part and you cannot query. So if this becomes complicated, overall this is not sustainable. But this is how you store the data in key value database, and this is how you get the data or read the data. Okay, so this was the first type of NoSQL database, key value database. Next, let's discuss about the document database for the same example. So one of the most famous document based database is MongoDB. So this is how the data will be stored in the document database, because in document database you store as a document, correct? And the format of the document is generally JSON or BSON. Here we have used the JSON. You can clearly see this is the JSON and this is the complete document. Inside that you will have the user ID 101, name as Rahul, and then you have this orders. Inside this you have all the information: order ID 1, amount 500, order ID 2, amount 300. So this is an example of embedded modeling style of document database where everything is present in the single document. Okay, so this was how we store the data, and this is how you read the data. You will do db.users, and then inside that you do .find and you pass the user ID here. So basically you can find inside the document as well. Okay, so users is kind of your, you can say, the overall document. Okay, or in SQL terms you can say it is kind of your entity. Inside that you can basically find. So you can find based on user ID. You can also find for the orders here. So that's a good thing in document database. Okay, so talking about the good and the bad things related to document database, The good thing is it has the natural JSON structure, as you can clearly see here. The in which we store the document is generally JSON, and it has the flexible schema. So as all the information is stored in the single document in a single place, you'll get all the data in one read. So that way it is fast, and overall it provides you the support of joins, although that is kind of weak support, but as compared to key value database, it provides you at least support for the joins. Okay, these are the good things. Talking about the bad things, so one thing that you can clearly see, because we are keeping all the data in a document, if your data keeps on increasing, your document can become really large, and of course it has a limit. Then you cannot keep all the data in one document, then you have to do other modeling style that we discussed earlier. Okay, and then another issue with it is, like, although it supports the joins, but the joins are quite limited and weak in document database. So yeah, of course, as compared to key value database, it's better because at least it provides the support for joins. In key value database, you don't have any support for joins. But when we talk in comparison to SQL, we have like limited or weak joins in document database. Similarly, the transactions are weaker as compared to SQL. Next, let's discuss about the same example in wide column database, which is the third type of NoSQL database. We discussed about key value database in NoSQL. We also discussed about the document database in NoSQL. Now, the third category of NoSQL, wide column database. And a very famous example of wide column database is Cassandra. Now, because in wide column database, we have the row key, we have the column families, columns and values. So here the data will be stored using the row key, which is user ID 101. So the row key here is user ID, and we are talking about ID 101, correct? And the column family would be orders, and in that you will have these columns: order 1 having the value 500, order 2 having value 300. If you have more data coming, so more columns will be generated. So in wide column database, you have dynamic columns, and you can have thousands or millions of columns, right? And this is how you can read the data in the wide column database. Select star from orders where user ID equal to 101. So basically you should know the row key and the partition. Now let's see pros and cons of wide column database. It is good when you have massive write throughput. Okay, so it is good in like write operations because we only do append only. It is also perfect for time series. In ascending order, we already have the data related to timestamp, so it is good for storing time series data. And it is also good when you have huge amount of data, like the data keeps on increasing, because here the columns are dynamic. You can create more columns and you can have millions of columns, and that too dynamic. Different row keys have different amount of columns as well, so it's totally fine. So these were the good things of wide column database. When we talk about the bad ones, you have very limited queries. You can clearly see in the queries you need to know the partition, and you also need to know the row key, and based on that only you can query. Okay, you don't have